Hello and welcome to this new section of the course, and this is the very first lecture where I'll give you a demonstration of what you're going to be building in this section. So this is one of those sections of the course where you're going to build an application. This particular application is a website with Python. So yeah, Python can build websites, just like other programming languages do. Of course, you need HTML and you may need CSS and JavaScript as well for the client side to render the web page on the browser. But on the backend, you use Python, just like you do with PHP and other programming languages. And yeah, the website that you're going to build is this one here that you see. I mean, it's quite empty for now, it doesn't have any content, but you can fill it with content and use it as a showcase for your work, as a portfolio or anything. So once you reach this point, you can improve it with easy. Also note that this website is now live, so I'll teach you how to deploy a website on a live server so that everyone can browse, can visit your website. So it's a complete tutorial to build a website from scratch and make it work online. Now this is a static website, but later in the course we have other applications where you'll be building more dynamic websites with a database on the backend and also some dynamic features. But this is a great point to start. So yeah, I hope you enjoy this section, and if you have questions, just feel free to ask. And yeah, I'll talk to you in the next lecture. Hello, and in this lecture you will build your first website with Flask, if you haven't done so already. And Flask is a Python framework that has all the tools and the templates and the functions for you to build websites with Python. And before going deeper into Flask and explaining you how to use Flask properly for building Python web apps, I would like you to spend 30 minutes to build a very basic website with Flask. And that is done with only 7 lines of Python code. So that's what we'll do right now. To build a web app with Flask, you need to have Flask installed. So pip install Flask should install Flask in your Python environment. Alright, that was successfully installed. And let's create our website now. What you need is a Python file. So I'm creating one here. Let's say script1.py. And then here is where you write the code that will build your web app. And everything starts from importing Flask. And actually you don't import the Flask framework, but you import the Flask class from a Flask framework. So from Flask import Flask. And Flask is a class of this library, and this contains all the prototypes that you need to build web apps with Python. So this will handle requests for you, you don't have to set up requests yourself. But let's focus on this example for now. Once you do that, you need to create a variable where you'll store your Flask object instance, your Flask application. That will be equal to the Flask class, and you pass the name variable in there. Just don't worry about that right now. Then you need a decorator, root, and here is the URL where you'll view your website. So this slash here means the home page. And just after that you need to write the function, the Python function. And this function is what defines what your web page will do. In this case, we will return a string. Let's say this string here. Website content goes here. Just after that, you need 2 more lines of code, and that's a conditional statement. If name equals the string main app.run, debug equals true. That's it. Don't worry about this right now. Just click save, open the terminal, and execute your script with Python. Script1 Python, yeah. And it looks like your web app is running now, so open the browser. And your website should be live on your localhost. That's it. Nothing impressive, but you see how easy it is to create a website with Python. And in this case, we are just returning a string here to the website. So there's nothing fancy in there. But later on, I'll explain to you how you can return HTML pages instead of plain Python strings to your website. That will allow you to actually have different formats, different fonts on your text. And then you can also apply CSS styling to your HTML, and so you'll have a complete website with modern features. For now, let's make sure you understand these 7 lines of code. Yeah, it's 7 lines. As I said, the first line, you are importing the Flask class object from the Flask library. Then in the next line, once you have imported the Flask class in here, the Flask object in other words, you are instantiating that class, that object. And this here is a special variable that will get as value the name of the Python script. Now, when you execute a Python file, a Python script, Python assigns the name main, this string, to the file. When you import a script into another script, like if we import this script from another script, this script will be assigned the script1.py name. But when you execute this script, Python assigns the name __ main __. So what happens is that in this line we say if name equals to main, then run the app. And this is true when we execute the script as we did here. But if we imported this script from another script, this line here would not be executed. So this allows us to have control over this script using this line here. Then we have these 2 lines. This is a decorator. Now the output that this function produces will be mapped to this URL. So if you want, you can change this URL to this, for example. Save the script. Sure, you need an URL here. Save the script, run, and go to the localhost, reload, and this time you'll get an error. Python couldn't find this page, but it can find the about page. Yeah, that's it. If you still want an home page, you would add another decorator and another function just after the decorator. So just leave this the home page and just say home page here. Save. Again, we have an error because we cannot have functions with the same name. So we can change this to about. The name doesn't matter, so this doesn't have to be the same with this one. Click save. Run the script again and go to the website. This is working. Try the web page, the home page, and this is working too. If you want to change something, let's say about content goes here, you save the script and the web app will restart by itself, so you don't have to close the web app and run the script again as I did earlier. If you get an error like I got previously, the script will stop, but if everything is alright, you will not get an error, so try this again. Home page is fine, the about page is fine too, and with the new content. So that's about it. In the next lecture you'll learn how to return an HTML template, an HTML file using your Python functions. That will give you full power to publish anything that you want in your website and not just plain strings as we did in this lecture. So see you in the next lecture. Welcome again. In this lecture, you'll learn how to generate HTML pages using your Python web app. In the previous lecture, we simply returned some plain strings, as you see here. So return a string. Now we will return an HTML template in here. And to do that, we need to use the render template method of the Flask library. And what render template does is accesses an HTML file stored somewhere in our Python application, in our Python files, and then displays that HTML on the requested URL. So we need to replace this with the name of an HTML page, let's say home.html. And this name here, this file name, has to reflect a real HTML file, which has to be stored in a folder, which itself has to be named templates. So be sure you use these names when you create a folder. Inside the folder, then, you need to create an HTML file, home.html. And the name has to reflect the name you are returning here in the render template method. That's it. And here is where you write the HTML code now. If you know HTML already, this should be as easy as breathing. If you don't know, then it should be easy to learn. If you know a bit of Python now, which you should, learning HTML is just a breeze. So just go ahead there and learn some HTML. It's that easy. But anyway, I'll create an HTML file here. Everything starts with a declaration of the document type, HTML. Then you have the HTML tags. That was the opening tag, and you also have the closing tag. That's it. You have body tags. Just like that. And inside here goes the content of your web page. So let's say I want a heading like this. And inside here you can put some text. My home page, for example. And yet another different type of tag, which is a paragraph tag. And say this is a test website. Click save. And yeah, you should be good to go. Go to your script, make sure you have saved it. And the web app is restarting, and I'll go now and visit my home page. This is the about page. This should be the home page. Yeah. I seem to have a little typo in here, I guess. Yeah, this should be h1 as the opening tag. Click save, and you don't have to rerun the Python script. Just go here, reload the page. And this is a normal text now. So this is a paragraph, and this is heading. Great. So we can also have another page for the about page. If you want, just quickly duplicate this. Say about my about page here. This is a test website. Again, just like that. You go to your script one and change this to render template, and there you pass about.html. Click save. Go to the localhost. This should be the home page. You have the about page. Yeah, my about page. This is test website again. So that's it. That's how you pass HTML templates to your Python web app. And that's how you map them to your URLs. Let's move on then to the next lecture. Okay, in this lecture I'll continue working on the website. And specifically, I'll be adding a navigation menu so that the user can easily navigate through the pages. Let me illustrate the idea first. First, I'd like to execute what we have so far. So Python script 1. So the application is running. And if you go to your browser, your local host, the default port is 5000. And this is the website. And we also have two pages here, about page. Good. So about page and home page. Now what I'll be building in this lecture is this thing here. I have a screenshot. So the home page, the about page, home page, the about page. So what we have is a navigation menu here, which if you click one of these texts here, you go to the specific page. And we also have a heading. And something you should notice now, which is important to notice, is that this part here is the same in both pages. That means we will add this part here, the code of this part, in each HTML page. How does it sound? Well, it doesn't sound very smart to me. A smarter way to do this would be to actually create a separate HTML page for this part here, and then link the about page and the home page to this page. So that's what we'll be doing in this lecture. So we need to have the HTML code for this header here and the navigation menu. And I already have that code, so I'll not go and type down all the HTML code here, alright. But I'll explain to you what the HTML does. So first of all, I'd like to actually double click this and just show it locally. So we're not running this on a server, I just double clicked it. So we have the header here and the navigation menu, which if you click you don't go anywhere because we haven't yet linked the layout.html page with the about and the home page. And as you can see, I put this inside the templates folder. So every HTML page goes to the template folder. So what we have here is we have the document declaration and we have the HTML tags then, closing here. Then we have a header element, and this contains a div here, and we'll be using this class name later to refer from our CSS code. Then we have a function here which says URL for, and what this does is that this will trigger the home function, the Python function, which we have here. So this one here. This function will be triggered when the home link will be clicked by the user. So this one here. And so the same for the about. So when a user clicks about, the Python function will be executed and the about.html file will be rendered through the render template method. So I hope that is clear. If you're lazy like me and you don't want to type every line of this file, you can find this file in the resource section, which is on the right of the screen. Now we need to figure out a way to link this layout.html file with the home and the about.html pages. I'll quickly go back to how the page looks like. And so as you see here, we have the header, and just down the header we have the about.html page. So just here. That means just under the header we will enter some code that will link to the home.html page or the about.html page, depending on what the user will click. And so we'll have a div division here, closing it. And I'll give it a class name so that I can refer later to the CSS code. Then you have curly brackets. So that's the syntax, and you also have to use %sign there. Then you write the block tag, and then you give a name to the block. And what we're doing here is actually template inheritance. So the layout.html page, which we are modifying right now, is a base template. The child template will be the home.html page or the about.html page. And these child templates will fill in this block here. And there is another line inside curly brackets and %signs as well. That is the end block keyword, which indicates the end of the block. And we are done with the layout.html page. What I'll do here is go to panes and split the window right. So I have the layout.html page here, close it here, and I'll go to the home.html now. And because this will be a child template, I don't need the declaration here and the HTML tag, and I don't even need the body tag. I'll replace this with a div, and let's say class equals home, and close it here, and delete this too, And what you have to do now is use the templating syntax again, like that, and use the keyword extends. And then you declare what you want to extend. So layout.html file. Then you also need another line. And here you need to specify the name of the block. So this needs to correspond with this one here. And so what's going on here? Well, let's go to the script, to the Python script. What happens is that when the user visits this URL, so the home page, or this one, let's say this one, Python will execute the home function, because the home function is mapped to this URL. And the home function will render the home.html template. So Python will go to the home.html page, and it will see that the home.html page extends the layout.html. So this one here. So what it will do is that it will send this code in this block in here, and then this page will be rendered in the home URL. So as simple as that. The user will see the layout.html page with its child content. So this is a base template, this is the child template. And we also have another child in this case, which is the about.html. So let me bring this here. And I'll just copy this and put this here, and this as well. Ctrl C, and yeah. Make sure you have saved all the files, and this one, yep. And let's take a look if the app is running. Yeah, it looks live. And I'll go to the home page. Yeah, looks good. We have home and about. Let's go to about link. Yep. We seem to have lost the heading here, the format of this line. Let's have a look at the about page. Yeah, I forgot to close the div here. Save again. Go to the browser. Reload. And it's fine. So that's about it. I hope things are working on your side. If not, please feel free to ask a question. Or you can even check my files, which I am putting in the resource section on the right of your screen. And yeah, I think our application is ready for more. So let's move on and see you in the next lecture. Great, we have progressed quite a bit. We have a Python script that generates a Flask app, and we have two functions. And each of them maps two HTML pages to two different URLs. And this is our website with two web pages. In this lecture, we will add some CSS styling to this website so that this looks just like any other modern website, and it is visually appealing and it doesn't look like in the 80s. Alright. To do that, we have to do basically two things. The first thing is we need to create a CSS file and write the CSS code inside it. And the second thing is, once we write this CSS code, once we have the CSS file, we need to link to it from our layout.html file. CSS is as easy as HTML, so if you don't know it, I would suggest you look at some tutorials, and I'm sure you'll get used to CSS very quickly. And I already have a CSS file that will stylize my website. I'll cut this and put it in a folder which I'll call static. Inside here I'll create another folder and call it CSS, and I'll paste the CSS file just inside here. So let me close this. As you see, the folder I created and the file has been reflected in the tree view here inside Atom. So the idea is that Python looks for static files in the static folder. So here inside static folder you can put different files. For example, if you want to add an image to your website, you'd create a folder here called images and then put images inside that folder. Then you can link those static files from your layout HTML page or from any other pages. Now, before opening the CSS file and going quickly through it, I'd like to show you how you can link to the CSS file. Now remember, the visible part of an HTML code goes inside the body tags, while links, like links to JavaScript files or links to CSS files, go outside of it. And those should be put inside head tags. So head here and head there. And then we have a link tag. And the rel there means the relationship. So the relationship to the file we are linking to is a style sheet. So we are sort of declaring the type of the file we are linking to. So it's a CSS style sheet. And then we have the reference here, which will be equal to the URL for function, which takes as argument the folder name where the file is located and file name parameter, which is equal to CSS main.css. So what we got here is we declare the type of the file we're linking to, and then we put the link of the file, and it should be in quotes, so all of this. And I'd also like to add a title for the website. Let's say Flask app. That's it. I'll save this and I'll go and try out the website. Whoa, can you see the difference? Yep. We have the menu here very nicely, about page, home page, and we have the title just here, and then the content of the web page goes here. Now all these bars here, the background color, the paddings, all these have been defined using CSS. So let's go ahead and have a look at the CSS code. Here it is. I believe this is quite self-explanatory, but anyway, what we have is basically this is an HTML element. So the body is here. And once we write the HTML element in the CSS script, we use curly brackets, and then inside the curly brackets we define these attributes. So the margin, the padding, and the font family for the text, and the color of the text. If you want to change this, let's say 999, save and go to the web page, reload, you'll see that the text got some different color. So this is quite grayed out. So that means this attribute here is affecting the body of the website. I'll put this back to 444. Then you have the header element, which is responsible for this header here, so at the top. Then if you want to stylize a specific part of your web page, let's say only the logo, which is this one here, you'd have to refer to the header first, and then to the h1 element, and then you refer to the logo class. So this is a class name, just here. And so on and so forth. You can look at this code at your own pace, I believe. So the logic is the same. Great. And now we are ready to deploy this website online on the cloud. So we will do that in the next lectures. See you there. So we have a running website, which looks quite good. The problem is that this is in our localhost. So the only person seeing this is, you, or someone who has access to your computer. So what we want to do instead is to deploy this website on web server or on cloud, as we will do in this course. And we'll be using the Heroku cloud. Heroku is a service that allows you to deploy Python applications in their cloud. The good news is that you can deploy an application for free, and you can have your public domain for free as well. Though you'll need a subdomain of Heroku, so something like, let's say, ardit.heroku.com. However, if your site will have a lot of traffic later on, you'd want to actually upgrade your plan and buy more bandwidth. Deploying on Heroku is relatively easy. You don't have to think and to do any administrative work. So Heroku saves a lot of time and effort so that you can focus on programming instead of the server parts. Before deploying to Heroku though, we need to do something. There is something that we should have done since in the beginning of this section, so even before writing any file here. And what you should do is that you should create a virtual environment which is isolated from your other files and from your main Python installation. So to run our application we use Python, which is coming from our main installation. So this one here, the ones I have here. This is not a good practice. A good practice is to actually have a clean installation of Python, which is used only for your application. So in that installation you don't want to have libraries installed, libraries that you don't need for building Flask applications. Therefore we need to create a virtual environment. And here I'll show you how you can do that. To create a virtual environment you need to use a virtual env Python library. And to use the virtual Python library, you need to install virtual env. So pip install virtual env. So we are using the main Python installation here to install virtual env. Great, that was successfully installed. And now we will create a virtual environment. The virtual environment should be created at the same level with the main folder that holds the application files. So if we go to our directory, just here is where the files are. And what I'll do is create a main folder in here and call it my site. And I'll close Atom for a while. And this would go inside this. So just here. And now you can open Atom in this directory, because here is where we will create the virtual environment. So let's open the command line now, and we are ready to create a virtual environment. And to do that you should use the virtual env library by saying Python, the env argument, then you have venv, which is the name of the library, of the module, and m here is an argument which allows Python to locate modules for execution as scripts. Then you need to specify a name for the folder where the virtual environment files will be stored in. So that should work. Let's see. The virtual folder was created. And yeah, the environment was created successfully. What we have here is an isolated installation of Python. And inside scripts, you'll see that you have Python there. Here it is. Okay, don't worry about that. And here is pip as well, so pip.exe, and that means you can use that Python if you like. Let me try out. So we are now at the my site directory. That means we need to refer to virtual scripts and Python, and that will trigger our fresh Python in the console. However, we are not interested to actually run Python from the shell, so I'll just exit this. And what we're interested instead is to actually run the Flask application using the fresh installation of Python. But before we do that, we need to actually install Flask in our virtual Python if you like. And to do that, you need to use the pip library of your isolated Python. So you need to point to the virtual folder, to the script folder then, and then to pip install Flask. And so Flask is installing, and it also installed its dependencies. And we should be good to go now. So let's run our web app using our new installation of Python. To do that, you need to point to the new Python, and that to demo, because we are in my site now, as you see here. So demo / script 1.py. That should work. Great. And if you go to the website now, you'll see that it's working fine. That's it. Now you are more than ready to deploy your Flask application on the cloud. And we'll do just that in the next lecture. And I would like to mention it again that Please keep in mind that you should always create a virtual environment before you create your Flask application. So before writing any code, you should use a fresh installation of Python. Let's go ahead now and deploy our Flask application in a live server, which in our case would be the Heroku Cloud. There are around, let's say, 15 steps to go through for deploying your Flask application on Heroku, and we'll go through all of them step by step. And before we go to step 1, I would like you to know that if you're aware of deploying websites that are built on PHP, based on PHP, with these websites, it's fairly simple to deploy them. All you have to do is just upload all the HTML and the CSS and JavaScript and the PHP files as well. You can upload them to your server directory using software such as FileZilla, and then you're good to go. However, with Python, the process is a little bit different. You'll deploy your application from your terminal, from your command line, from your computer. So there are a series of commands that you will want to give to the terminal so that we have these files uploaded in Heroku. So yeah, I suppose now you have a running website. So your Flask website is running correctly on localhost, and you also have a virtual environment which we set up in the previous lecture. So let's start with step 1. Step 1 is you go and create an account in Heroku. So it should be somewhere in here. So you go to sign up and just create an account. So once you have that, then you can go ahead and log in. And yeah, dashboards should be your homepage once you log in. And under personal apps, which is this one here, you'll see your apps listed in there. Now, if you have just created an account, you'll not have anything, but I have this test 702 which I have created. And so the idea is that you first need to create an account in Heroku, and then you create apps. Now, to create an app where you'll store your Python files so that you can access the website from the web, you can either go here to the plus sign and then create new app, or you can do that from the command line. And that's what we're going to do. So we're going to be using the command line to do everything. Yeah, basically we're done with the web page of Heroku. So step 1 was to create an account. Step 2 is you need to download the Heroku tool belt. Heroku tool belt. So it's served by Heroku. This is a tool that allows you to communicate with the Heroku server through your command line. So yeah, basically we'll be sending commands to the Heroku server, and we need to download and install Heroku for that. So just go ahead and choose your Heroku for your operating system, and then just go ahead and install it. And once you have done that, you go ahead and go to the directory where your main file is, your Python file, and shift right click for Windows and open a command window here. So you can either do that with Terminal Plus inside Atom, but my Terminal Plus is not working at the moment, so I'm using the simple command line, which is the same thing. I mean, it's nice to have the terminal inside Atom here, but this is also the same thing. So I am in the demo folder, so demo, where my script 1.py file is. So what I'm going to do is point to Heroku and login. So you can do that after you have installed Heroku tool belt. So what I'm trying to do here is log in to Heroku so that I can send commands to the Heroku servers. And yeah, my email was auditsuche.com. So that should be the email that you use to create an account in Heroku, and then the password that you chose there. and execute. Oh, my login failed. I seem to have entered the wrong email, sorry about that. Login again, or did switch Hotmail. Yeah, now it should be fine. Now I'm logged in successfully, so I can go ahead and send commands to Heroku. So yeah, at this point we have covered 3 steps. We created an account on Heroku, and we installed the Heroku tool belt, and we logged into Heroku. Now we need to create an app. To do that, you again need to point to the Heroku command and then create, and then give a name to your app. So let me try Ardit there. I say I'll try because sometimes an app name can be already occupied by someone else, because you know the name that you give to your app will be set as the domain of your web application. So it would be something like ardit.herokuapp.com. So let me try this. And yeah, that was successful. Obviously there are not many people named Ardit, so that was good. And yeah, if you want, I mean this is not a requirement, but if you want, you can list your apps using Heroku apps, just to see what apps you have. And yeah, I have now 2, Test 702 and Ardit. And yeah, great, now we have an app on Heroku. And if you want, you can go and access your app, actually visit your app, Ardit.heroku.com. So heroku.com or herokuapp.com is the same thing. So basically what we have is just a default web page there that is waiting for some custom files to build a website. So in our case, we want to upload a Python application, and then we will have a website based on that. And yeah, this is how your app should look at this point. You know, this is different from, let's say, a random name that doesn't have an app. So this says no such app, but our app says welcome to your new app. So let's go ahead now and upload our files there. Now to upload files into Heroku, we should use Git. Now Git is a version control system, and it allows us to deploy an app to Heroku. And now you should have Git installed. But the good news is that Git is installed by default when you install the Heroku belt. So Heroku belt is based on Git, and it installs Git for you. But if for any reason you don't have Git, then you should be able to just search on Google for Git and just go ahead and install it. And once you have Git installed, then we go ahead and initialize a Git repository. But before we do that, actually, we need to have 3 files in our app directory. So I'm talking about this directory, which is where our main Python file is located. So script1.py file, because here is where we have the app instance. So we are creating this Flask object here. In here, what you want to do is open a command line, or you can use this one, but I wouldn't interfere with that. So let me open a command line in there, and we need to create 3 files. The first file should be named requirements.txt. So we should create 3 files, and then we upload these files together with our Python file and the CSS and the HTML files to Heroku. And Heroku will recognize these files because we'll give them specific names. And so in these files we'll give some instructions. The first file is a file called requirements.txt, and what that contains is it should contain a list of dependencies that you want Heroku to install in your Python, in their Python installation. So we have Python and we have Flask installed in our virtual environment. So we should find a way to tell the Heroku servers that please install Flask for us. And that way is by creating this requirements.txt file. So I'll show you how to do that in a bit. Now we have Flask installed, and you can have a list of all packages and libraries and modules that you have installed in your Python installation with pip freeze. So that should list all the packages and libraries and everything. Beware though that what I used is pip freeze, so I used the pip of my main Python installation. So we're working on a virtual environment, and what you want to do is you want to point to your virtual pip, so to say. Now my virtual pip is, somewhere here, and so here is the demo folder where I'm currently demo. So you should be really careful with directories. Then back, so demo virtual scripts, and here is my pip. So just there. That means this is the current directory. So I need to go back one directory. With 2 dots you go back one directory and then point to virtual, and then script, and then pip, and then freeze to get a list of packages that you have with your virtual environment. And yeah, I have Flask and its dependencies. Now we need to insert these in a requirements.txt file. Before doing that, actually you need to install one more library that is called Gunicorn. Like that. Yeah, pip install Gunicorn. Let me expand this. Yeah, that's all I can do. Install. That was successful. So why do we need this library? Well, this is an HTTP server, so we need the server, actually, Heroku server needs this to run your web application. If you do pip freeze again, you'll see that Gunicorn is there, and you also see the versions on the right. So to throw this in a file, you can do something like that, and the name of the file, requirements.txt. Yeah, that should be okay. Great. This is a file, and yeah, we have all the dependencies there. Great, so that was the first file that I mentioned. We have 2 more files to go. The next file is a proc file, but be careful, you shouldn't have any extension in there. So that's a file without any extension, and just go ahead and edit it with whatever you want, or Notepad, or just here in Atom. So this should contain a line, and that would be web Gunicorn corn. So what you're doing is you're telling Heroku what to use, what web server to use to run your application. So we're saying use Gunicorn, and then Gunicorn has to point to script 1, so that's the name of our file, and a colon there, and then app. So again, a proc file is in the same directory with our script1.py, and it should be there. And then what you do, then you point to the file name of your Python file name, and then app is the name of the variable that is holding the Flask instance, so app there. Yeah, I hope that is clear. That's all you have to do with proc file. Just save that and close the file. And yeah, one more file now, and that would be a runtime file, runtime.txt. What that should contain inside is the Python version that you want Heroku to run your app with. You can make it without creating a runtime.txt file, but in that case, Heroku will run your application using Python 2.7. So that version. If you want to run your application, so if you want Heroku to run your application with Python 3.5, you'd say Python 3.5.1. So why did I insert this? Well, Heroku actually, they have these 2 available runtimes. Now, so supported Python runtimes. you can either specify this, which happens to be the default one, so you can get away without specifying this. And then they have 3.5.1. If maybe you have 3.5.2 in your computer, but that doesn't make any difference. So if you have 3.5.2 or 0.3 or whatever, you still have to specify 3.5.1 in the runtime.txt file. And yeah, save that. And all we have to do with the files. Eventually we can go ahead and upload this file to Heroku. All these files that we have in this directory here. Great. To do that, you first need to create a Git repository. So you say git init for initialization, execute that, and as you see, you got a .git folder created in there. So that contains your local repository. So in other words, these files now are recognized by Git and they will be uploaded into Heroku. So this is how this looks like. And now we want to add these files to the Git repository. To do that, you say git add and a dot. So what the dot says is, you're adding the files of the current directory. So the dot points to the current directory. And yeah, that was successful. And then you want to commit the changes. So you added some files, and later we will see when we make changes in the website, in the web application. And whenever you make changes, you say git commit with the m flag, and then you have to write some nodes there. Let's say first commit. When you do the second commit, maybe you change something in your web application. Maybe you added another web page in your website, and you'd say something like web page added or something like that. So this says 8 files changed. So why 8 files? Well, we have 1, 2, 3, 4 files in here, and we have 3 here, so 7, and 1 here, main.css. So we have 8 files that were actually added to the local repository. The next step now is to push the changes to Heroku. So we want to push to upload the Git repository, the files, to Heroku. However, first you need to do something. We have 2 apps in our Heroku account, but we haven't told Heroku which app we are working on. So to do that, to point to one of your apps, you want to do Heroku git remote, and then the app flag, and after that goes the name of your app. So everything that you do now is applied to the app that you referenced in this command here. Now, to push the changes to Heroku, so to eventually upload the files, you do git push Heroku master. Now, if you're doing this for the first time, you may get an error from Git saying that Git wasn't able to recognize you. In that case, if you get an error from this after executing this line, you can go ahead and authenticate with Git. That's actually very easy, so nothing to worry about. You say git config and global with 2 dashes in front, and then user.email, and then in quotes you want to pass your email. You can use the email that you use for creating a Heroku account, so something like .com, and you execute that like that, and then you need to do one more thing. So again, git config, and then global user.name, so the username this time. Just pick a username that you want, just like that. And once you have done that, then go ahead and push the changes to Heroku. So that would be again git push Heroku master. So I'm providing all these commands in a separate file, so in a text file, and you can find this in the resources in this lecture. There you'll find the commands in the correct order, as we are executing in this video. Execute, and hopefully this will be successful. Python app detected. So yeah, something important is that you want to be in a directory where your Python file is located. So that's how Heroku will detect that you're running a Python file. If you're, for instance, if your directory, your current directory, here would be something like website my site. Here, so website my site and not demo. So if you would be somewhere here, Heroku wouldn't be able to push the changes. So, and yeah, this verifying deploy done. This was successful for me at least. And now you can go ahead and browse to your web page. So in my case, it'd be audit.herokuapp.com, or you can open the browser by doing Heroku open in the command line. And yeah, here we go. My app is live now, and it's a working app, so I can navigate through the website and so on. So yeah, that was about this lecture. And you know, Heroku info, you can get info about the current app. You know, you have things like the git link in there, and the owner, and the URL of the application and so on. And that was about how to upload a Flask application into Heroku. This is a bit delicate work if you're a beginner. So if you were unable to do this, then you could download the text version of the commands and try to run them again one by one. And you can also ask questions and just tell me about the error you're getting, and I'll try to help you. And yeah, we still have one lecture to go. In the next lecture, what we'll do is I'll make a simple change to the website and see how we can upload the changes to Heroku. So we're talking about maintaining our website now, our web application. And yeah, let's move on, and I'll talk to you in the next lecture. Well, here we're going to talk about how to maintain your website. And by maintaining your website, I don't mean you have to go to your website every day to check your files and see if it's running or not. So that process is automatic. You don't have to do routine maintenance. But what I mean by maintaining your website, I mean, you may want to change something from your website. You may want to add a page or update a page or change the CSS styling or add another function to your Python script, etc. Only in rare cases you build a website and you put it online and then you don't change anything. That doesn't happen very often. And yeah, so how do we go about updating something from our website? Well, now our files are both in our local file system, so which is here in this directory, but they are also on Heroku. So if you want to change something, you'd first change that in the local directory. For instance, let's say this is the about.html page, and what I would want to do is I want to add another line. So I'll paste that, and let's write something. This was added later. Now the middleman here is Git. So Git serves the role to connect your local files to the Heroku server, which means now that you made the change, you can save your changes, and then you can push the files again to Heroku. And actually, if you save the file now, Ctrl S, you'll see that in the atom directory tree, the about.html file name was colored in orange. That means you haven't pushed the changes for that file. So in other words, the file is different from the file that you have on Heroku at the moment. But if you test your website on localhost now, you'll see this change. So let me do that. And before I do that, I would like to change something on the CSS file as well. So 060, save that. And you see that CSS is also colored in orange. So I'll save that and go to the demo directory, or shift right click. I'll just go ahead and execute script1.py. using my virtual Python, so to say. Yeah, that is running. So just go localhost. And yeah, this is the web page. So about. Yeah, we have 2 lines now. This was added later. You can also see the change that I did in the CSS file. So now the text color is green. Sometimes you may not see the changes right away, the changes that you do to your CSS file. In that case, you want to press Ctrl R to clear the cache when reloading a web page. So we're talking about the localhost now. Yeah, once you see that the website is working well on localhost, so you make sure your website is working perfectly, then you upload the files to your live server. So you test things first in the development environment, which is my local computer, and then you push those changes to production. So yeah, I can go ahead and close this. And let's go ahead and now apply the changes to Heroku. So to do that, again, you would open a command line in the root directory, which is demo in my case. That's the directory where my Python file is located. Yeah, so you need to log in again, Heroku login. Enter your credentials. Alright, so logged in successfully. And then, to make sure that you're connected to the appropriate Heroku app, you could try Heroku info. And that would return ardid for my case. We suggest that Heroku knows what app you're pointing to. So if you don't get any information on this, if you get a message saying that you haven't specified an app, then you go ahead and write the command that we used in the last lecture, which was Heroku git remote, and then you specify the app flag, and then you pass the flag, the app name, sorry, like that. You execute that, and then you're connected to the ardid app in my case. In your case, should be the name that you have specified. Yeah, once you do that, then you could try again Heroku info to make sure you get the credentials for that app. And then you go ahead and add the changes to the Git repository. So that would be git add and a dot, like that. Execute, and then you need to commit the changes with git commit, the m flag, and then you write something here, a note. You could say, normally you write in the current tense, which should be add text to about.html. And the other change that we did was change heading color. So that's the 2 changes that we made. Execute that. And yeah, you should see a message here saying that 2 files were changed. So we changed the about.html and the main.css file, and we inserted 2 pieces of information. So the first one was this paragraph line here. This was added later. And the next one was 060 that we added in the CSS file. And we also deleted something, which was 444, so the previous color that we had for the heading. And yeah, once you commit the changes, you want to push them. Git push Heroku master. Alright, that was successful, so now you go ahead and open your website. Yeah, your website should pop up. And then you can see that the new changes have been applied. So we have this dark green color there, and the about page should also have 2 pieces of text here, so 2 lines. And yeah, that's about it. I hope I was clear in explaining this, and it's quite a safe method to apply changes. And I hope you enjoyed this section of the course, and we'll move on. We have more applications to build, and you have quite a lot of things to learn by building them. And yeah, I'll see you in the next lectures. Thanks. Hello, and welcome to this new section of the course. In this section, you're going to learn how to build graphical user interfaces with Python. And specifically, we're going to use the tkinter library for that. So in this section, you're not going to build any real world program. I'll introduce you to the tkinter library, and of course build a graphical user interface, a small program that can get you started with tkinter. And then in the next section, so once we are done with this section, in the next section you're going to learn how to interact with databases with Python. So we'll be using Python as a wrapper of SQL code, so that we can store data in a database, query data, delete, and so on and so forth. So that was the section after this one, and then in the third section, after these two sections, we're going to build a real-world program. And that program is this one here. So I called it bookstore, and what this does is it allows you to store book information in a database. And this is a graphical user interface. So this program is made in two parts. You have a graphical user interface, which are these buttons here, which are called widgets, and this was built with tkinter. And then you have the backend, which consists of code that communicates with a database. So, for example, if we press the View All button, we are querying the database to load all the books for us. So, we have the title, so if you press one of them, you get the title here, the author, and the year of the book, and also the book identification number, which is called ISBN. You can also search for an entry, so if you want to search for an author, you write the author name in here and press search. And if you want to add an entry, you just type that in. And yeah, something like that. Add entry. And if you load them again, your entry should be here. So this is the program we're gonna build two sections after this one. So let me close this one here, and in the next lecture I'll introduce you to the tkinter library. So we'll be building some simple interfaces with some widgets. See you in the next lecture. So here we go. I have opened up Atom here, so I'm going to use Atom to build the bookstore program, so to say, that uses tkinter and SQLite 3 as libraries. So I'll go ahead and create a new Python file in here. Call it script1.py. Now, to build graphical user interfaces with tkinter, you need the tkinter library, and you don't have to install it because tkinter is a built-in Python library. So all you have to do is go ahead and import tkinter. If you are on Python 2, this would be with a capital T. In Python 3, it's tkinter, simply like that. Good practice, however, is to actually import everything from tkinter. So from tkinter import all. So why we do that? We do that because we're going to use a lot of tkinter objects in our scripts. So it makes sense to just load them all instead of referencing them with tkinter.button, for example. Instead of doing that, we can just say button and then we enter the parameters and so on. So let me create a graphical user interface then. Now, a tkinter program is made up of two main things. We have the window and you have the widgets. So, for example, the window is all this program here that you see, and then you have buttons and things like that, which are called widgets. So first of all, you need to create the window, and I like to call my variable window, and that would be equal to tk. That's it. That would create an empty window for us, but we need to do something more here. We say window.main loop. This is always necessary, so we open a window, we create a window, and then everything goes between these two lines, so you create widgets between these two. And this is necessary because if you don't have this, your program will open up and it will close in a split of a second, So basically this allows you to actually press that X button on the corner of your window and close the program. So this should be always at the end of your code. Now I'll save this script and going to execute it. And we got an error. It says tk is not defined, so Python is not recognizing this function here because it should be capital T. And execute again. And this is the window. And it has nothing inside, so let's go ahead and add a button. So we store the main window in a variable, and we're going to do the same for widgets. So we're going to create variables. Let's say b1 equals to button. So the button is a function that generates a button widget. The button function takes some arguments. If you want to get a full list of arguments, you'd want to do some code introspection. Let's say IPython here. And from tkinter import all, and then let's say button and a question mark. And here you can see what parameters you can pass to the button function. Now the very first parameter you'd want to add to a widget is the variable of the window, of the main window. So you need to tell your widget the window that the widget has to be packed to. So window, and then you can pass parameters like the one you see here. Let's say one of the main parameters would be text. So text equals, let's say, to the string execute. So that is the text, the label that will be displayed over the button. Now if we try to execute this script now, you'll see that we don't have a button yet. And that's because we haven't specified where to put that button. To do that, you need to use the pack method, which is a widget method, and then execute again. And now you see the button. However, there is another way to actually put your widgets in your window. That is the grid method. And often is a matter of preference, so whether to use pack or grid. But the idea of grid is that with the grid method you have more control on the position of your buttons and your widgets in general, because here you'd specify the row and the column where you want to put your button. So everything starts from 0, and so the first row has an index of 0 and the first column has an index of 0, and so on. I actually found illustration for that. So this is a tkinter program, and we have two rows here. So we have this first row which would have an index of 0, and you have the second row which would have an index of 1, and you have columns, so 0, 1, 2, 3, and so on. Let's say the OK button, which is this one here, would have a row of 0, 1, 2, so 2 for the row, and then 0, 1, 2, 3, 3 for the column. And then you might also have widgets which span in more than one row or column. In that case, you'd add another parameter here called row span. And that would be equal to a number. Let's say if you put 2, the button would span in 2 rows. In our case, this is not necessary actually, because we don't have lots of widgets, we only have one button. And so let me execute this script now and see what we get. So we get a button, which actually does nothing because we haven't specified what action to perform when you're pressing the button. And I'll explain that in the next lecture, but for now let's add some more widgets here, just for you to get more familiar with widgets. So let's add an entry widget, and let's say E1 for that. So entry1 equals to entry, and then guess what is the first parameter, and that's the window parameter. And we can leave it like that for now, and let's say a E1 grid and row, let's keep it in the same row, and in column 1. Save, execute. And here we have an entry. So what's an entry? An entry is like an area where you can enter a value and then you can interact with that value in your script. So let's say you enter kilometers here and you'd want to have a button that converts those kilometers to miles. So the button would get the value of this area here and it would display it in another widget, which could be a text widget. So let's add a text widget. Let's say t1 equals text window, of course. And let's say t1 grid row 0 column 2. That's it. Execute. We got a very big text widget because the default size, the default height and width is actually quite a big number, so we need to specify 2 parameters for the text widget. We would need to put the height, let's say 1 cell, and the width, let's say 20. And so this is the widget area, and this is the entry, and this is the button. And that's it for this lecture. In the next lecture I'll show you how to put these widgets in live so that they can actually do something. See you in the next lecture. Hi again, and in the previous lecture we built this graphical user interface with Tkinter, but the problem is this does nothing for now. So we press this, but it doesn't do anything. So what I'd like to do here, the final output I'd like to have is when I execute this button. So we have an entry here, we can input a value, and I want to execute this button and get miles here in the text area. So miles is like 1 kilometer unit is equals to 1 mile times 1.6. So if I execute this, I want something like 16 here to be generated. So a very simple program. Note that this is not one of the real programs that I've promised to build in this course. So this is just to get you up and running with Tkinter. So let's close this now. And to have a button do something, we need to add a command parameter here. So the command parameter takes a function here as argument, as a value. And then when you press that button, the execute button in this case, the function that you have here will be executed. So let's say we have a function here, def kilometers to miles. And let's say this function for now, it just prints out some text. Let's say success, for instance. Because you know it's good to, before you write your actual program, it's good to use print statements to try things out. So that allows you to isolate your problems. If something happens here, you know that you can have a problem with a print statement, but if you had a more complicated expression here, it gets harder to know whether the problem happens in here, that you are not pointing to the correct function, or you have a problem with your statement. So it's good to use simple statements first, like the print statement. So you'd go here and kilometers to miles, that is the function. And one thing you should keep in mind is that you don't pass brackets here. So this is not a usual function call. You are just referencing to the function here and let Python take care of the rest. So the function name goes here, and let's try this out. Execute, and you see that we got success printed out in here. Press again, success, success, success. So it's working. However, we don't need to print out success in the command line. We want to print out a value in the text area. Now we need to look at the entry widget, because here is where we are going to get the value from. So the user enters a value in the entry widget, and then we grab that value, and then we use that value in our function. And for this, there is a parameter called text variable. and that would be equal to a string var object, which we have to declare further up here. So let's say e1 value, so that's a variable, and that would be equal to the string var function. And then we point to the e1 value variable, which we have just created. So this variable will get the value depending on what the user will input in the entry widget. Then we can use this value whatever we like. Let's say we want to print that out, a value, and we also need to add something extra here, which is a get method of the string var object. So this is a special object, it's not a string, a Python plain string. To get an actual string from out of this object, we need to apply the get method. So save this and try the script. Let's say 10 here, execute, and we get 10 printed out on the terminal. So we haven't yet connected this string here with a text widget. So let's do just that here. The idea here is that we need to insert a value to the text widget. And to do that, the text widget has a method called insert. So you need to refer to the text widget that you want. So t1 is our text object, and then apply the insert method. And the method gets an argument first, which is a place where you want to insert the text. Let's say we want to insert at the end of the text widget. For example, let's suppose you are inserting many lines of text in your widget, and you'd have to apply to execute this method multiple times. And each time, if you put end, you'd enter the new text at the bottom of the existing text. So you're saying put at the end this text, e1 value dot get. So the string of the value that the user will enter in the entry widget. So let's see how this goes. Execute the function and put some text here. You can also put anything. Hey there. Execute, and you get the string printed out in the text widget. Alright, but we don't want to just grab this value and insert it in the text. We want to first do something with this value, and then we insert the product, the output, in the text widget. So let's say we will grab the e1 value dot get, and we will multiply that by 1.6, and that would be miles. So miles equals to the value that the user inputs times 1.6. So you are asking the user to input kilometers, and 1 mile is equal to 1 kilometer times 1.6. Actually is something like 1.606. I don't remember the exact value, but you get the idea. And lastly, you'd want to pass miles in here. So you would want to insert the miles output value in the widget. Save and execute. And I expect to get an error here. Let's say 10. Yes, we got an error. And so when you get errors, don't just try to copy this error and paste it on Google and try to see what other people are saying. You may waste a lot of time. Instead, invest some time and try to understand this error. So what this is saying, it says type error can't multiply a sequence by non-integer of type float. So a sequence can be a list, can be a string, a tuple, etc. And Python is trying to multiply a sequence with a non-integer, which is a float. So a float here is the 1.6 number, and Python is trying to multiply 1.6 with a sequence, with this here. So this is not a number, because the get method actually grabs a string out of a string var object, and a string cannot be multiplied with a float number. If this was 2, it was possible to multiply. For example, if you multiply me, the string me, times 2, you'd get me. So, but you cannot multiply me by 1.6 because it doesn't make any sense. Anyway, so the solution to this is you want to convert the value that the user inputs to a float. And you do that by adding the float function. So watch out for the brackets here. You see there is an underline under the bracket and you have an underline here. So this means this bracket closes in here. So everything looks fine. Save and execute again. 10 and execute. And we get the expected output. You can delete this print function, we don't need it anymore. And I believe that was a good start with the Tkinter library, and you should now be able to make more advanced interfaces. However, we will be building a real advanced graphical user interface with Tkinter, which will interact with a database. So it will be a real world program. And for now, I'll just hand you an exercise in the next lecture, so that you practice Tkinter a little bit, and you also get to know with some more cosmetic aspects. So you'll make the program that we built in this lecture, you'll make it more visually appealing, and you'll make sure you'll get your hands dirty with Tkinter a little bit. I'll talk to you later. Hi there, and I'm glad to introduce you to this new section of the course. And in this section, you're going to learn how to interact with databases via Python. And what that means is that you'll use specific Python libraries, and you're going to operate a database from Python, using Python. You're going to do operations such as inserting data into database tables. You'll be able to update data, delete, and query data all from the database. And then you are able to use those data in your Python program. Python is able to interact with many databases such as MySQL, PostgreSQL, Oracle, or SQLite, etc. In this section, you're going to learn how to interact with an SQLite database and a PostgreSQL database as well. SQLite and PostgreSQL are different in that SQLite is not a client-server database. Instead, it is embedded into the end program. So what does that mean? Well, let's look at this program. If you follow the previous section, you know that we're going to build this program in the next section. When you click a button here, you see some data, and these data are stored in a SQLite database. In contrast to other databases such as PostgreSQL, SQLite is based on a file. So all these data here are stored in a .db file, database file. So that means you can just give this program to someone else who don't have SQLite installed, and they can use this program. So they can add more data here, can update data and delete them and so on. But if you have this program in a PostgreSQL database, the user you give the program to, they would need to have PostgreSQL installed in their computer to be able to operate the data. So consider SQLite a small database, and you can call it portable, but it's very popular, and PostgreSQL would be more appropriate to use in a web application. So let's say you have some forms, you're getting some data from the user on your website, and you store your data on a PostgreSQL database on your server. And Python is a program that gets this data from your forms on the client, on the browser, and sends those data in your database. Now, to be able to interact with these databases, you need to have two libraries, and these libraries serve as interfaces to actually send SQL code to the database. And the library to interact with an SQLite database is called SQLite 3. And the library to work with a PostgreSQL database is psychopg2. So in this section now, in the next lecture, I'll show how to work with SQLite 3, and then we'll jump to psychopg2. So let's move on. Alright, in this lecture, you're going to learn how to use SQLite 3. So SQLite 3 is a Python library to interact with SQLite databases. So think of it as a Python wrapper of SQL code. So you can actually write SQL code inside Python using SQLite 3. You don't need to install SQLite 3 because SQLite 3 is a built-in Python library. So all you have to do is import SQLite 3. Let me test it. Script 1. Yeah, it's working. Now, a standard process of interacting with a database would consist of 5 steps. First is you connect to the database. Second is you create a cursor object, and the cursor object is like a pointer to actually access rows from a table of a database. Then the third step is you apply an SQL query, so you may want to insert data in the database or select data from the table and so on and so forth. And then the fourth step is you commit your changes to the database, and then you close the connection. So let's go ahead and write an example with all these 5 steps that I just mentioned. So the first thing, you need to create a connection, and you want to store that connection object in a variable. So let's say con that would be equal to SQLite3.connect, and what you pass here is the database file. So let's say lite.db. And if you don't have a database file yet, your database will be created by this line of code, and a connection will be established. If you have a database, a connection will be established with your existing database. As simple as that. Then you have to create a cursor object. So cur, the variable, and you need to refer to your connection and then to the cursor method, which is a method of the connection object. So far so good. Then here comes the actual SQL code. You want to point to your cursor object and then use a execute method, and then inside brackets is where you enter your SQL code. And remember, your SQL code always goes inside quotes, so you pass the SQL code as a string to the execute method of the cursor object of the SQLite 3 library. So if you're familiar with SQL, this should be easy for you. If you're not familiar with SQL, SQL is quite simple, so you'll be able to learn it quite quickly. So at this point we have a database, but we don't have any tables in the database, because you know a database is made of tables, and tables have rows and columns. So first you want to create a table, and a good practice is to use capital letters for the SQL keywords. So create is an SQL keyword, and table is an SQL keyword as well. And then you want to specify the name that you want to give to the table. Let's say store. That's how you order Python via SQL to create a table, but then you need to specify what columns you want, what fields you want in your table. So let's suppose we are creating a table. We have a store, we have a shop, and we want to store our products in a SQLite database table. So we would want to have the item, so that would be the item name, and the item would be a text data type. So text is like strings in Python, and then you'd want to have quantity, and that would be an integer. So how many of this item you have in your store, and the price as well. And let's say real for the price, which should be a float in Python, so a decimal point number. And that's it. Here closes the quote of the SQL code, and here is the last bracket of the execute method. Then you need to commit these changes to the database. So you refer to the connection and then commit, and then you want to close the connection. So that's it. You save that and go and execute. QLite is not defined, of course, because I have made an error here, a typo. And again. And as you see, a database was created. Now, if you run the program again, you'll get an error because the table already exists in the database. So what you could do here is a simple trick. You need to add some code in your SQL line. You say create table if not exists. So save, and if you run your code again now, nothing will happen, because what Python does is it goes and connects to the database, then it creates a cursor, and then if there is a table called store, it doesn't do anything and it goes to the next line. If there was no table, it would create a table. So it's good to have this simple conditional here inside the SQL code. How about adding some data to our empty table. Let's try that. Cur execute. So we are executing some SQL code again, and the keyword that inserts data to the database is insert. Then you want to specify where you want to insert the data. So insert into store, and what values you want to insert to your store table. So values. Then you open brackets, and inside the brackets you enter the values in the correct order. So in the order that you have defined your columns. So you'd have item, quantity, and price. And let's say wine glass. Now this is a string, so it should go inside quotes. And you should use single quotes here because you are using double quotes for the outer expression. So if you use double quotes here, you will confuse Python and you'll get an error, so use single quotes. That's why we have different kinds of quotes to wrap around strings. So we have the string wine glass, and let's say we have a quantity of 8 and a price of 10.5. Save that and go ahead and execute. We didn't get an error, so that was successful. Now, what if we want to insert another row? Well, we could add that line in here, under this, but then when we execute the code, we would get this line executed as well. So we would have a duplicate of this row. Therefore, what we could do in this case is we would use a function to wrap around our separate SQL statements. So you can indent this block of code. If you like, you can go to edit, lines, indent, or you could use a shortcut which can be specific in your keyboard. So just look here for your shortcut, keyboard shortcut, and then you can just use that. So the reason I'm indenting the block of code is that I want to create a function here. Let's say function create table. Don't forget the colon there. And then I want a separate function for inserting data. So that would be the SQL statement for the insert function, but you can see the difference between this function and this function. Here we are not creating a connection to the database, which is wrong. So you'd want to insert these lines in here so that you establish a connection with the database, and then you correctly close that connection. So you know how to use Python functions now. Naturally, the need comes to pass parameters to your function here. So you'd want to say item, so just some variables, and quantity, and price. And then you would want to somehow replace these parameters in here, so that every time you call the function, you insert some arguments, and that those values are inserted to your table. Now you can use string placeholders, Python string placeholders, to replace these values with the values that the user will pass when they call the function. But this is not a good practice because your code would be prone to SQL injections from hackers, and that applies when, of course, when your web application is on the web. But anyway, a good practice is to put question marks in here, and then after the SQL statement, so after the double quote, you'd want to pass the variables that these question marks could be replaced with. So you'd want item, so in the correct order, quantity, and price. So let's try this out now. I would like to execute the insert function that I just created with some new items. So let's say water, glass. We have 10 of them, and this would be less expensive. Save that and go and execute. I made a terrible error here. I wrapped with quotes all the arguments. So water glass should be in quotes, and these are numbers. So save again, try it again. And your data should be now in the database. So one more time, and let's say coffee cup. Save, execute again. And now I'm sure you would want to see the data that you have been inserting in your database, in your table. So let's create a function that does just that. Let's say def view. And you'd want to establish a connection with the database. So let's copy that and paste it here. And then here goes the SQL code. So cur execute. So we always use the execute method to send SQL code to the database. And then we have quotes. Let's say we want to select the data of all the columns of the store table. So select an asterisk, which means all, from store. Alright, so we selected them, but how do we actually fetch this data so that we can use them in Python? Well, the way to fetch them is by using the fetch all method. And we want to select to store those rows in a variable. So let's say rows cur fetch all, and then we need to close the connection. So in contrast to the other methods where we were writing data to the table, here we are just selecting data, so we don't have to use the commit method. And we want to return the rows variable. And I would just like to print out the output of the function. So the output of the function is the rows variable. So I'll get the rows value printed out on the command line. Save the script, execute. Of course I have a typo here and should be return. Try again. And here are our data. So we have wine glass, water glass, and we have 2 lines of coffee cups. That's because we executed the function earlier, the insert function, and then now that I executed the script again with a purpose to get the view function executed, the insert function was executed as well for the second time, so coffee cup was inserted 2 times in the table. Alright, that's for this lecture, and in the next lecture I'll show you some more operations you can do with the database. So, talk to you later. So, in the previous lecture I introduced you to the SQLite 3 library, and I showed you how to create a table in your SQLite database, and how to insert data in your database, and how to select data and view them in Python. So we have these 4 lines, 4 rows in our database table, and in this lecture I'll quickly show you how to delete and update data from your table. So again, I'll create a function. So let me copy this, and we still need to connect to the database and create a cursor object, and then we need to use the execute method. And in this case I would like to delete the row that has the wine glass. So inside execute we would write delete from store where item equals, I would like to use a question mark placeholder here, so question mark, and in brackets we would want the parameter that we would pass to our function. So this item here is the one we put inside here, item, and let me change the name of our function. So this is this one. Don't confuse it with this. This is the column of our table, and this was the row from the previous function. Delete this as well. And you also want to commit the changes to your database. So commit. So that's it. And I'd like to comment this out, so I don't want to execute the insert function again. And I want the view function to be executed after we delete the row. So delete. So which item, the row of which item would you want to delete? So the item wine glass. And let's see what will happen. And we got an error, an SQLite 3 error, incorrect number of bindings applied. Line 28, I can see here. Yeah, there is something I often forget. You need to add a comma here. You'll see that when I teach you how to connect to a PostgreSQL database and how to query data from the PostgreSQL database. The code is quite similar, but it has some critical changes like this one here. So it can be confusing when you work with different kind of databases. Let's try this out again. And yeah, it seems to be working now. Wine glass is not here. So that's how you delete a row. Let's now add another function for updating data. Update. In this one, I would like to update the quantity of water glasses. So I would want to change this from 10 to 11. Again, you establish a connection to the database, create a cursor object, and then you execute. And here you enter the update SQL command. So update, what you want to update is the store table. And which column do you want to update from the store table? So you want to set the name of the column, which in this case would be quantity. And that would be equal to what? Guess what? Question mark. And then you say where, or let me show you how to update more than one column. So if you wanted more than one column, you'd use a comma and then say price equals another question mark. Alright, so we say update store and set quantity and price to this, but which row? So you need to specify a conditional here. So where item equals to wine glass. Or you can also set this to a question mark, so you have 3 placeholders here. And then you have the quote to close your SQL statement. And then inside brackets you want to pass the parameters, quantity, and you have the second one is price and item. When you have more than one parameter here, you don't put a comma at the end, so this ends like this. And you also want to pass these parameters here, so they reflect your function input. So what we have here is we are updating the store table, and we set the value of the quantity column and the price column to these values, but only for those rows where the item will be equal to a given value. So we give that value to this one here, and the first two to these ones. So you get the idea. Save the script, and you need to call it here. So let me comment this out and update. So what quantity do you want to pass? 11, let's say. And the price was 5, let's say it will go up to 6. And which item you want to update? Water glass. That's it. Save your script and try it out. And we got these values updated as we expected. And that's what I wanted to teach you in this lecture. It could be more practical to actually have an ID here, so we say quantity and price where the ID is equal to a number, so we don't have to pass the entire name, which can be confusing, or it's prone to errors. So in that case we would want to change the table here, and we would want to add a primary key that auto increments. But you'll learn how to do that in the next section of the course. So there I'll show you how to make the real world program, and we will implement that in that program. So these were some trivial examples, and you'll get a much better idea in the next session. So next we will jump to PostgreSQL, and we'll work with the PsychoPG2 library. Talk to you later. Welcome to this lecture. We are done with SQLite 3, so I hope you were able to build this script that I showed you throughout the previous lectures. Because in this lecture, we are going to use this script, but I'll modify it so that it is compatible with interacting with PostgreSQL databases. So luckily most of the code is the same, with some slight changes. Of course, we would need another library called psychopg2, and then we will grab methods from that library. And unlike SQLite 3, psychopg2 needs to be installed, so it's a third-party library. It doesn't come as a built-in Python library. So you need psychopg2 installed, and you also need PostgreSQL installed in your computer. So in this lecture, I would like to show you how to install PostgreSQL and psychopg2 as well. Alright, this is the official webpage of PostgreSQL, and you can just go to downloads, just here or down here, and then you want to find your operating system. So PostgreSQL works on Mac, Linux, and Windows, Solaris as well. So I'm on Windows, so I'll just click on Windows, and when you install PostgreSQL, you are also installing the pgadmin 3, which is a graphical tool where you can see your databases. If you're familiar with MySQL, pgadmin is equivalent to PHP MyAdmin. PostgreSQL also comes with a stack builder, which is a package that you can use to download and install other PostgreSQL extensions. So let's say you want an extension for spatial data, so to store spatial data in PostgreSQL, so that you can use it for JS applications. So there's an extension for that called PostJS. So anyway, I'll show you how to install extensions. First, you need to download PostgreSQL, and I am on Windows, so I'll click this, and I'll wait a while until my download finishes. So I'll quickly go through the installation process. So I'm just being asked where I want to install PostgreSQL and where my data will be stored. And here you should be careful with these credentials. So your super user, the ones who have most of the privileges to your databases, and your super user name is Postgres, and I would actually like to create a simple file. A text file just to store my credentials. I would like to set a password as well. 1, 2, 3. Alright, so I would enter Postgres 1, 2, 3 for password. Then next, this is the port of your server, of your database server. So I would want to take a note of this too. This is about your local settings, so I'll just leave this default. And you'll just have to wait a while until the installation finishes. Alright, that was successful. Now if you want to launch Stock Builder to install extensions for the PostgreSQL database, you may want to have this checked. So this is my database server. And here you have a bunch of extensions that you may want to install. For example, spatial extensions. And you have PostGIS for 32-bit and for PostGIS for 64-bit. If I click next, this tells me that they need one package at least to be installed. So let me just install PostGIS. Alright, agree to the PostGIS license, and then just go next. This is asking me about GDAL, which is another interface for GIS data. Alright, that was how to install external extensions. If you want to go back to Stack Builder later, your Stack Builder should be here. Or you can just go to PostgreSQL, and here you have pgadmin as well, and here is the application Stack Builder. Alright, but if you want to work with Python, you want to access the PostgreSQL databases through Python, so you don't have to interact with these applications here. The way to interact with PostgreSQL with Python is by installing psycopg2, and you can install psycopg2 with pip. However, you may run into problems because psycopg2 is written in C, so you need a C compiler installed in your system. On Windows at least, you will not have this problem on a Mac and a Linux, I'm quite sure. The solution to this, actually there are a few solutions. One of the solutions is that you may want to install Visual Studio on your Windows machine. But that's quite a big program, and I wouldn't want to install that. So the second solution, which I prefer the most, is to use precompiled Python libraries. And you can find almost any Python libraries that require a C compiler. You can find those libraries in this page, served by Christoph Goldke. So we're looking for psycopg2. Here you have the wheel files. So a wheel file is a file that can be installed with pip. So what you do when you install something with pip install psycopg2. Pip is downloading the wheel file from a remote server, and then it installs it in your system. So here you can look for your version. This would be the file for my system. So I'll just get this from here and paste it in here so that I can access it from the Atom command line. So here is the file that I just downloaded. So just go ahead and pip install, and then you need to point to the will file. So .will. Alright. And that was successfully installed. I can quickly check if that is available. And it seems to be working. You can also check the version of your library if you want. So it's 2.6.1. Alright, so in the next lecture, we will connect to the database, to the PostgreSQL database. And then we'll be creating tables and inserting data, viewing, deleting, and updating them. So let's move on. Very good. In this lecture, you'll learn how to connect to a PostgreSQL database and how to create tables in a PostgreSQL database, insert data, view data, and delete and update rows as well. The script you're looking at now, though, is a script that you built in the previous lectures using a SQLite database. So if you haven't watched those lectures, I highly recommend you to go through them first, then you come here, because in this lecture I'll just go through this code and replace only a few lines of them. And that suggests that the code that you use for the SQLite 3 library is very similar to the code we will use for psycopg2, which is a library you use to connect to PostgreSQL databases. The main difference is that your database will not be a DB file stored in your file system. It will be a database embedded in your PostgreSQL installation. And so the first requirement is that you need to have an existing database in your PostgreSQL database server. And PostgreSQL comes with a default database, so once you install PostgreSQL, you'll have a database called Postgres. So you can just pass the database here, or if you like, you can create your own database. So you just need to go to your PostgreSQL installation, and you can create a database through pgadmin. So here are your database servers, and this is a default one. You need to connect to your database server first. And then this would be the password that you created when you installed Postgres. Postgres123 was mine. Alright, so I was successfully connected, and I have 3 databases. So this is the default database that I was talking about. These are 2 other databases I have created. So to create a new database, just right click on the databases and then new database. Let's say database 1. And you need to specify the owner, so the user of your database. Postgres, this is what I specified when I installed PostgreSQL, and this should be enough. Alright, so now you have a database here. If you click to that, you will connect to it. Now you can just close this and go back to Python. Okay, let me first comment these lines out so that when I execute the script, I don't get this function instances called. So we have an empty database. So the first thing we would like to do is to create a table. But first of all, I would like to change this to psychopg2. And of course, I would like to make a batch replacement of SQLite 3, replace it with psychopg2. So I want all these library names here to be replaced with psychopg2. So replace all and just press escape, and that goes away. Luckily this code is the same as SQLite 3 library, so we have connect, and then we have the cursor object, then we have the execute method, commit and close. All we have to do is change the parameters here. And here we would want to pass the database name, the username, the host, the password and the port number of your database server. And all that comes inside quotes. So it is passed as a string to the connect method. First we have the database name, so the parameter dbName, and that will be equal to a value. So you need to insert the value inside single quotes. So that is database 1, the name of the database. Then you have user, and be aware that you don't need to use commas in here. So all this goes as a string, and it is read as a string by the connect method. So user goes inside quotes, Postgres, then we have the password, Postgres123, yeah. Then you have the host name, so the host parameter, and that should be localhost. Alright. So localhost should be your host name, and it's always like that. And last we have the port number, and that goes inside quotes as well, so 532. So those are the parameters you pass to your connect method of the psychopg2 library. Then let's try to call that function. So create table is the function, and I'll save the script. So let me make sure you know what is happening here. So we connect to the database, and then we have the same methods for the psychopg2 library. So we are creating a table, name store, and then we have 3 columns for that table. And we commit those changes, and then we close the connection. So save the script, Ctrl S, and then call the script. And that looks successful. If you like, you can just go to pg_admin, and here you can see the table that you have just created. So just enter the password, and you need to go to your database, so database 1, expand that, then you need to go to schemas, public tables, and this is our table name. So we have the store table, and you got 3 columns, item, quantity and price. Alright, we have an empty table, so let's go ahead and insert some data to that table. I'll just copy this connection string and paste it in here. Then remember that we use question marks when inserting values for SQLite 3. If you want, you could use string formatting placeholders. So one for the item, the one for the quantity, and another one for the price. And then after the comma, let me delete this. After the quote, sorry, you would pass the percentage, so you already know string formatting, and then you specify the tuple of the variables you want to insert here. So item, quantity, and price. So you can use this, but this would be prone to SQL injections from attackers, so it's not a good idea. I can go ahead and execute this actually just to see what happens. So let's say Apple and 10 and 15 for the price, and let me execute this. So it looks like it worked, and we can check it in the table here. So you can just go to your database, which is database 1, and here you can execute a simple SQL query. Select all from store, and go to run, and you see that Apple was added to the table. So it works, but it's risky to use Python string formatting. So what you want to do is, I'll leave it for a while there so that you compare things out, and to avoid SQL injections, you should actually pass your variables as a second parameter to the execute method. So what does that mean is, you don't have to use quotes, so you just pass %s, just like that, and then you put a comma here, so that means this string here inside double quotes is one argument, and then this one here is the other argument, and then you pass your variables. So that should work now. So I'm sure you can see the difference between this and this, and I'll just comment this out so that it isn't executed, and let's say orange, same price and quantity, execute, and let's go and check in pgMadMean. So let me execute the query again, and you see that orange was added as a new row to the table. So this is the way to go, and I'll delete this. Alright, now let's look at the view function. So what the view function is doing is it connects to the database, and it selects all the rows from the store table, and then we store those rows in the row variable using the fetchAll method, and then we return those rows as a function output. Everything you need to change here is an argument of the connect method. So just put them here, and you should be good to go. So let me view, call the function, and execute. And yeah, we need to print it. Forgot it. Yeah. So we got Apple, and we got 3 oranges now, because when I executed the script here, I got the insert function executed again, so we got 2 oranges, and another one when you use the string formatting placeholders. So you get the idea. Let's look at the delete function. Again, we need to pass arguments of psychopg2 connection. Then we have delete from store, where item, again we can't use question mark, so we need to use %s. And then as a second argument, we pass the item variable. So it's the same as SQLite 3, but we use %s here. And let me call delete. I'll comment this out and delete here. So what you want to delete is the item. What item? Let's say we want to delete rows where the item is equal to orange. So let's see how this goes. And yeah, the item was deleted. The rows with the item orange were deleted, and we got the view function executed, so we got 1 row now. Our table has only 1 row. A quick look at the updates method now. Just like that. And here we are updating the store table, and there we are setting, so we are updating the quantity to this value and the price as well to this value, where the item is equal to this value. Alright, so we got 1, 2, 3 values, and we pass 3 variables here after the comma. So as a second argument of the execute method, and the update method gets 3 arguments, so let me comment this out. And update, we have only 1 row, so I'd like to set the quantity of apples to, let's say, 20, and the price, let's keep the price the same, and for the item apple, just like that, and execute, and we got the quantity changed to 20. So that was it. I believe that was quite simple, so if you learned SQLite 3 before, this was quite simple for you. And if you have any questions, just feel free to drop them in the discussion section. I'll be happy to answer. See you in the next lecture. Welcome to this new section, and in this section you're going to learn how to build a real-world program that allows the user to store information about books. So I have already built that program, and I'll show you step by step how you can do the same. I have the program here, and it's an executable file. So apart from learning how to build the .py program, you'll also learn how to build executable files that run on Windows and .app file that run on a Mac. So you can basically give your program to anyone, and they don't need to have Python installed in their computer. So I call the program Bookstore. And this was built mainly with Tkinter, which is a graphical user interface library, and the SQLite 3 library, which is a library to interact with SQLite database. So what we got here are 4 entries where you can enter a new book record. So let's say you got a new book in your store and you want to add it in your database. And here you can see all the books that have been added to the program. You can add a new book, let's say Pythons for the title, added quickly and 1918. You have the ISBN number, which is unique identification number for books. It's quite long, let's say like that. And you add entry, and then you view all again, and you'll see that the new entry was added to the database. So every record that you see here is actually stored in a table inside this Lite1 database. Then you have some other buttons here, so if you want, you can actually search for entry, for a record. Search entry, and then it will display the entry that you search. When you click on the entry, you get all the fields displayed in each of the text box here. So view all again, and you can also update and delete records. And finally you can close the window. So it's not a great user interface. I'm not a great user interface designer, but you will learn a lot by building this program. So it's quite a long one, but it will pay off. So let's kick it off. Hi there, and in this lecture what we're going to do is start to build our bookstore program. Specifically, we're going to work on the graphical user interface, because you know this program has 2 parts, so to say. So it has a backend and it has a frontend. The backend is the SQLite 3 database code, so the code that interacts with the database, and the frontend is the code of the Tkinter library. So the code that builds up all these buttons, these entries, this text, and this list box, and this scroll bar. So normally you'd have to choose whether you want to work on the backend code first, or you want to start building the front-end code. But first of all though, the very first thing you want to do is actually to start defining some requirements. So you want to say what your program will do. So let's say you want your program to show a list of the current records. So when you press view all, you see the list of records here, and then you want your program to search a current entry, and then you want to add entry and update and select data, and then you want the program to close the window. So basically these are our requirements, and now you can choose to start writing the backend. So you could write a function that selects all the data from the database, and then you could return those data as text, so you can just print them out just for now. If you want to write the backend first, because you don't have the front end, you don't have the graphical user interface built yet, so you can just write functions of the backend and then print out the output. Or you can start writing the front end first, so you build this graphical user interface, but when you click those buttons, nothing happens. So you just draw this thing with Python. And then once you have done that, you start building the backend, and then you connect all these widgets and all the commands of these buttons with your backend functions. So it's a matter of preference whether you choose to work with the backend or the front end first. In this course, in this section, we're going to build the front end first. So we're going to build a graphical user interface that will do nothing for a while until we connect it with the backend. Alright then, I would like to first remove this vertical bar here because I'm going to draw the graphical user interface here. So I'm going to make a sketch for you to see and to have the sketch in here all the time. So to remove this bar, if you're curious, you can just go to settings, and then there is a package that actually shows that bar that's called wrap guide, and you want to display, so this displays a line of the 80th character in the editor, and that may help you, if you want, may help you to keep a particular pattern. So you don't want to have more than 80 characters in your code, so that bar helps you keep that rule. Anyway, we don't want that, so I just removed it. And I'm just going to write a few notes inside the docstring. So you know that a docstring is like a comment line. So if you put anything inside these triple quotes, this is not read as code by Python, but it's just like a documentation string. So just for humans to read. So let's say I want a program that stores this book information. So title and author, year and ISBN. So the identification number for books. And the user can view all records. They can search an entry and add an entry, update an entry, delete, and they can close the program if they want. Close. Great. So if you start thinking about that, now you'd want to have a graphical user interface that has all these buttons, so that the user can do these actions through some buttons. And then you think about how they can view records, and you know that Tkinter has the list box widget that allows you to display text as a list, so line by line. And then you want the user to search an entry, add an entry, update entry. So you need some entry widgets. And then of course you'd want some labels that can tell what each entry is about. So that would be a label widget. And you may also want a scroll bar so that your list is scrollable. So if there are many records, the user can scroll through them and they can see the records under the list. And so we've got a sketch. This of course requires some fantasy and maybe some experience with user interface designing. But it's very important that you have a sketch. So I'm going to keep this sketch on the screen while I code the program. Normally in real life you'd want to have a drawing, maybe on a real paper or just on a digital screen. But it's important to have it, and now that we have it, let's start building it in the next lecture. Great, so now we have a sketch of our graphical user interface, and that should make things easier. So now you can just go ahead and code your graphical user interface in Python using the Tkinter features. So Tkinter is a library that we'll be using to make this interface. And I suppose you already know Tkinter because I explained that in one of the previous sections. So if you don't know Tkinter, please go back 2 sections before this, and then you'll be able to understand what I'm talking about here. So I'll keep the sketch on the right. And now you know that to make a graphical user interface with Tkinter, you can either use the pack methods to pack your widgets or the grid method. We'll be using the grid method, so it could be a good idea to actually make a grid on your sketch. So that when you create your widgets, let's say you create a button, you'd want to pass the number of the row and the number of the column. So having a grid like this will make things easier. Alright. And I'll just like to delete this doc string. We don't need it, and it saves me space so that you can see more a cleaner workspace here. Alright, from Tkinter import everything. So I'm not explaining the code now because you already know these things. If there is something new, I'll go through it. Window equals to tk, so the tk method that creates a window object, and then you want to apply the main loop method, which is basically a way to wrap up all the widgets that you will enter in this space now. Alright, so we have 4 labels here. So we have a label title and author, year, and ISBN. So I'm just going to create 4 labels, or 4 label objects. So I'll name my objects, my variables, from L1 to L4, and we use the label object, label method for that. Window is the parent window, and text would be title. So Control Enter, you can go to the next line, no matter where you are in the previous line. So you don't have to just switch, go to here and then press Enter. You just press Control Enter and you go to the next line. L1, you apply the grid method. So the first label is on row 0, and column 0 as well. Then you can just copy this and paste it 3 more times. So that would be L2, L3, and L4. And you'd also want to change the text of your label, year, and ISBN. Author would be column 2, as you see from the sketch. So 0, 2, then we have the year would be 1, 0, and then 1, 2 for the last label. So let's see what we have. I'd just like to call my script. Alright, looks promising. Now let's add the entries. So these were static widgets. Now we need to add some entries. So E1 would be entry, and an entry gets the window as the first parameter, just like any other widget does, and also a text variable parameter. This text variable parameter, this expects as an argument the value that the user will enter in the entry widget. That is a spatial data type. So you first need to actually create a data type here, an object with of that data type. So let's call it, we are creating the entry for the title, say title text equal to string var. So this is the function that creates this spatial object, and that would be equal to that title text. So that's it. And you also need to grid this entry widget. So grid, and the first widget, so the title widget, corresponds with row 0 and column 1. So that's it. I can quickly multiply this here, and author text, here text, and ISBN text. You also need to change the numbers of your variables, just like that. And of course you need to pass that these user entries in here. So this should be n and these two. Alright, and lastly you want to specify the rows and the columns for these entries too. So E2 would be 0, 3, and then we have the year text widget 1, 1. Alright, and the last entry 1, 3. Alright, let's check it out. Yeah, looks good. Great. And now it's the turn of the list box. So let's call it list1, why not? And that would be equal to list box window. And then you would want to specify the height of your list box and the width as well. So I thought about putting 6 and 35. It would be good height and width. You can taste different heights and width and see what comes better. And then I'd like to grid this. So grid, and so this would start at row number 2 and column 0. However, if we leave it like this, things will not go as we expect. Actually, we can try this. And as you can see, the list box occupied only the first cell. So the first cell of the first column on row 0, 1, 2. So row 2, column 0. What we want instead is to span this list box on the other columns as well and on the other rows, because we'll have buttons here later, so we'll want to span that. And you can see the sketch here. So we can add a row span parameter, and that would be equal to 6, and column span as well, so that would be 2. Alright, so that would be a list box. However, we also need to actually add a scroll bar there, so that the lists can be scrolled when there are lots of data in the list, lots of records. To attach a scroll bar to the list, the logic here works like this. You create your scroll bar, and then you tell your scroll bar about the list that the scroll bar has to scroll. And then you tell your list as well who its scroll bar is. So let's first create the scroll bar, an independent scroll bar. So let's say sb1 scroll bar method, and that is attached to the window. And then you apply the grid method. So the scroll bar would be on row 1, column 3. And once you created these two objects, you want to apply a configure method to the list box and a configure method to the scroll bar object. And these configure methods get arguments. So this would be scroll command equals to sb1.set. That's it. So meaning that the vertical scroll bar along the y-axis will be set to this scroll bar. And then you go to the scroll bar method. Sorry, this has to be configure. And then you pass command equals to list1.yView. So that should work. You are passing a command parameter here, so meaning that when you scroll the bar, the view, the vertical view of the list will change. So let's see how this goes. And seems like I've messed up something here. I have put the position of the scroll bar on row 1, I guess, and column 3, yep. So the scroll bar should be actually row 2, column 2. Let's check that again. Yep, seems to be working. Though it doesn't look very centered because we need to span it through the same rows as we have spanned the list box here. So we need to add here a row span parameter and set it to 6. And now the scroll bar looks centered. Alright, so now what we have left is to add these button widgets just here. Great. So we have 6 buttons. Let's start with the first one. We have the button method, window and text, so buttons have text. View all is the first one. And then I thought of putting a width of 12. So B1 grid, that would be row 2, column 3. And we have 5 more buttons. So I'll paste this. Six, I think. So B2, B3, 4, and 6. Of course, these buttons don't have a command parameter now, because later we will add here a command parameter, and that will decide what the buttons will do. But for now, that is just fine. So these buttons will be aligned in column 3, all of them, and everyone has a different row value. And 6. Great, so let's see what we got. And boom! I forgot to put a row number for the close button. So 7. And now it looks better. So this was how to build a graphical user interface. Of course, these buttons don't do anything for now. So in the next lecture, I'll show you how to attach actions to this graphical user interface. So we will work on the backend, and we'll be using SQLite 3 for interacting with the database and fetching those data in this graphical user interface. So I hope my routines and my practices will help you to build graphical user interfaces with easy. And I'll see you in the next lecture. Hey, welcome to this new lecture, and here we are continuing to build our bookstore program that stores and retrieves book records from a database. So far, as you know, we have built the graphical user interface with Tkinter. So this is our script. So basically we have the front end of our program. And now, so this is our graphical user interface. And basically what we need to do now is to attach some functions to all these buttons. So let's say, for example, when we press the view all button, a function will be triggered that selects data from an SQLite database and then gets those data and put them on this list box here. So that means we need to create a database, an SQLite database with SQLite 3. We also need to create a table first. So we could do this in this script, but I prefer to actually create another script and then import that script in here. So import, let's call the new script backend. So we need to create a backend.py script. Alright, and I would also want to change the name of this, of my front-end script, so that we keep the same pattern. So let's say front end. Alright, so we are in the front-end script now, and here we are in the back-end script. So what that means is, let's say you create a view function, so that selects data from the database, and you create that function here, and then you go to the view all button, and then you would add a command parameter here, and that would be equal. So let's say command, just to give you an idea, command equals to backend and the name of the function. So something like that. All right. Hope this makes sense. However, for now it would be great if we forget about this script. So we need to keep in mind the graphical user interface, but it's good not to interact with these widgets for now. So what we do instead is print out the outputs of our functions, the functions that we'll build as strings in the command line here. So we'll not throw those data in the list box, but in the terminal here. Alright, let's start coding. Import SQLite 3. That's the first thing you want to do. And I'll keep an image of the graphical user interface here so that it's easy for you to refer to it. So we need to create a view function. But before that, I would like to create a database, so a connection to a database. And I would like to put that inside the function. So let's say function connect, and we have a connection object, so that would be a SQLite 3 connect, and let's call the database books.db. Alright, so we establish a connection to the database. Then we define a cursor object like that. And next we need to execute an SQL statement. So cursor object execute, and inside double quotes we input the SQL statement. So we have a database, and we also need a table in the database where to store our book information. Now think about that. When you give this program to a user, they will execute the program, and every time they execute the program, your script has to check if there is an existing table in the books database. So if there is a table, you say don't create the table. If there is not a table, you'd want to create the table. So create table if not exists, and let's call the table book, just to differentiate it from the database name. And then you'd want to pass some parameters. The first parameter I would like to pass is the ID. So don't confuse this with the ISBN number, the book identification. This is just a number that will start from 0 and it will auto increment by 1, so that we have control of how many records we have in the database. So it's a good idea to have this ID here, and that would be an integer. And you need to set it to primary key. So that's a mandatory column in your table. Then you have title as text, author as text, year as integer, and ISBN, that's an integer as well. Alright, that's it. You want to commit your changes and then close the connection. Alright, so we created a connect function. Later when we will run this script, so the front-end script, and then you import backend, this script, the script of the backend, so the code of the backend will be read by Python. But if you haven't called this function, this code will not be executed. So what you want to do instead is have this function executed anytime you execute this function. So you execute front end, and this imports backend, so it executes all the code, and this line here is executed, so the function will run anytime you run front end. Alright, I hope that makes sense. Or let me quickly explain that better. So we have an a.py script and we have a b.py script, and in the a.py script we import the b script. And what we have in the B script is a function foo that prints out something on the screen. Hey, and save this and save this as well. So when you execute a.py, nothing happens for now because you have just defined your script. But if you call this script here, alright, foo, save, and execute a again, this time you will get the output of the function. So that's the idea. Thanks. And back to our real world script. Alright, now we have the connect function. Let's start by creating an insert function, a function that will insert some data in the database. So I'm starting with the insert function because that's an easier function than the other one. So I'd like to start from the easy things first. Def insert. So that's how I call my function. And think about that, you have 4 entries there. So you expect from the user to enter a title, author, and year, and an ISBN number. So you want to pass 4 parameters here. And ISBN. Alright. And then of course you need to connect to the database. Because this function here, it will just connect to the database temporarily, and it will check that if there is a table, and it will close the connection. So you have a closed connection here. When you press the insert button, when you press the add entry button, you need to create a new connection to the database. And let me go ahead and get these 2 lines as well, because we need them too. Alright, and here is where we execute our specific SQL statement inside quotes. So what the add entry button will do is insert into book, so the table book, values. And here is a trick now. We have an ID here, so this is an auto increment value, so we don't have to pass that manually. And what we can do instead is pass a null value here, and Python understands that, and it will create the ID automatically. And then we have 4 question marks, 1 for each of our values. And then you need to pass your parameters as a second parameter of the execute function. So as a tuple here, title, author, year, and ISBN. Alright, let me write another function, and then we execute the script to try it and see how it is going. So def, let's say the view function. So this will fetch all the rows of the table. So we copy this and put them here. So we connect to the database, create a cursor object, and then we execute an SQL statement. And then, because this will be a select statement, so we will not perform any changes to the database, so we don't need a commit method here. And this is actually quite simple. Select all from book. So you actually need to return your selection as a tuple, and then you grab that selection and you put that in the list box. So you want the view function to return a tuple. So let's say rows equals to cur fetch all, and then you can close the connection, but your data will remain stored in the rows variable, so you can just return rows here. Alright, so let's try out the script now, and the way to try it out would be to use a print statement. So we would want to call insert, and then we would enter some data manually. So in the real program, this insert function will be executed somewhere in the add entry button. But for now we need to keep things simple and reach our objective step by step. So insert, let's pass some values here. Title, let's say the C, and then author John tablet. Alright, and year is an integer, so you just need to pass a number, and ISBN also is an integer, so no need to put them inside quotes. And then you'd also want to print out the output of the view function. Great. So let's see how this goes. That would be the back-end script. Great. So the record was inserted into the database and it was printed out from the view function. If you execute the script again, you'll get 2 records because the insert function was executed 2 times. Alright, seems to be going well. So what else do we have? We have a search function. And we would implement an OR search. So what that means is that the user will enter a title or an author name, or the year or the ISBN number. Or he may choose to enter all of them at the same time. But if, let's say, he enters the year only, he'll get all the rows corresponding to that year. So here we need to pass 4 parameters as well. ISBN, alright. And then we need these lines of code. So connect to the database, cursor object, and then execute. So let's stay here for a while. We want to select all from book where title is equal to something, or author is equal to something, or year equals to something, or ISBN. And then the second parameter would be the tuple of the arguments. Title, for year, ISBN. And then we need to fetch all the rows that will be returned from this query and store them in this rows variable. Close the connection and again return rows. Alright. One problem here though that we may encounter is that the user may want to pass, let's say, the author name only to the entries, so this function will get only the arguments for the author parameter. These other parameters will remain without a value, and then you'll get an error because your function is designed to have 4 parameters. In that case, you'd want to pass some empty strings as default values. Alright. And these 2. So now if the user passes an author name, let's say John Smith, this SQL statement will search for an empty title, or for the author name John Smith, or for an empty year and ISBN and so on, and it will return all the rows with John Smith as author name. Alright, so let's save this and try it out. So we have connect, insert, print view, let's say the earth, I'm inserting another record here, John Smith, alright, and then let's say print search, and you want to pass some arguments, for example, author equals to John Smith, alright, without a quote here, and let's see how this goes. So we got here this list of rows from the view function, because we also have the view function here, and then the search function returned this row for us. So the row with ID 3 and with John Smith as author. So that is working well. let's go ahead and build a delete function now. So let's think about how the user wants to delete a record. So most probably they would want to see some records in the list box, and then they would want to select one of the records. Let's say the record for ID3, the Earth, John Smith, etc. So they would select that and then would press the delete button. So that means we would want to first grab the list selection, so the selection from the list box. We would grab that as a tuple, but we'll think about that later. So we'll grab that as a tuple, and then that tuple has a unique identification number, so the ID. So we would want to refer to that ID and then go to our database table and delete the row with that ID. So hope that is not very confusing. And in the delete function, so we would expect the ID of the tuple that the user will select. And then we would want to have this code and start from there. So connect to the database cursor object, execute a statement. Alright, let's see how this goes. So we want to delete from book where ID is equal to something. Great. And then that something is the ID parameter, so the argument of this parameter here. And this is the column name, so don't confuse this with this column name function parameter. And don't forget the comma here. And yeah, that's basically it. Let's save this script now and let's execute it. We insert some data there, let's say the sun this time. And so we'd have the sea again, the earth, and the sun. So I'd like to delete the earth. And I would want to put them in here, delete. So earth has an ID of 3, so we'd want to pass 3 here. And then we would view all the current records once we have deleted them. Alright, so here are our records, and the earth has disappeared. So it's working great. Again, as I said, this ID will be extracted from the tuple, so the tuple will have the ID as a first item. And so basically we'll get from tuple get the item with index 0, and we'll pass that first item to this delete function. Great. The last function would be update. And again, how would we want to update records? So how would the user want to update a record? Well, again, they may expect to select a row from the list box, from the Tkinter list box, and the values of that row would display in the entry widgets. And then from there, the user may want to change one of those cells, of those entries, and press the update button. So again, we will get a selection from the list box, and then we would refer to the ID. So ID here as the first parameter, but we would also want to get the new values that the user would want from those entries. So let's say the user wanted to change the title from the sun to the moon, let's say, and you'd get that title, so the title will be in the entry box, and pass it here. Same for author, year, and ISBN. Alright, and then you'd want to update your table, so update table where the ID is equal to this, update table with this new values where ID is equal to this. First of all though, we need to get all these rows. Alright, so update book, and you say set, so the keyword set title equal to question mark same year question mark and ISBN equals to a question mark. So update book and set these values where ID is equal to another question mark. So then we pass the tuple here. So ID, title, author, and ISBN. So it's looking good. We commit the changes and we close the connection. And let's see how this goes. So currently we have these rows in the table, the C again, the sun. Yeah, these 3 rows. And let's update the sun. So I'd want to comment this out first and also delete. So let's focus on the update function and update. So you would want to pass the ID of the row so that you want to update, and then you want to pass the values in the correct order. So what you want for the new title, let's say the moon. And then in the real interface, in the graphical user interface, if the user wants to change only the title, he'll leave the other values as they are, so these values will be replaced to the existing values. So John Smith and year 1919, the ISBN number. But in this case we are just in a test mode, so we can pass these values. Smooth, alright, and a number. So let's see how this goes now. And it seems it didn't work. The sun is still there. So let's see what we got here. Update title, author, year, ISBN, where ID is. So the ID should be at the end of the tuple here. Because we put them in the correct order that we have set here. So let's try this out again. Now it's working. So the ID 4 was replaced to the moon, John Smooth, and the other values. Great, so I think we have the backend script ready. And what we need now is attach all these functions to our buttons. So we still have work to do, and we'll do that in the next lecture. Hey, welcome again, and this is the final push that we will give to our application. So by the end of this lecture you'll have a fully working program that can store and retrieve book records in an SQLite database. So as you know, we have 2 scripts. We have frontend.py and we have the backend.py script. We are completely done with the backend.py script. So we have built all of our functions that connect to the database, insert, view, search, and delete and update data. And now we need to go to the front-end script, because we need to tweak it a little bit so that the front-end script is able to get data from the back-end script, or more specifically is able to get the function outputs, which are basically tuples of data, and then insert those tuples of data in the list box. So basically the user presses a button and then these functions are triggered and the data are inserted to the list box. So let's start from the easiest things. And the first thing I would like to implement is to get the records in the list box when the user presses the View All button. First of all, as I mentioned before, you need to import the backend script in here so that you are later able to refer to your functions as something like backend.view, for example, for the database view function. Now, I have been mentioning that to attach a function to a button, you need to go to where you have defined that button, so to the button function, and then you add a command here. So command, and then here goes the function. Now if we just call the view function of the backend script, so if we do backend.view, all we are doing is just executing the view function, so we aren't inserting any data to the list box. So what we want to do is have another function and have that function grab the data from the view function and insert those data to the list box. For example, let's call that function view command. Just like that. Remember, you don't pass brackets here, because if you do, when you execute the script, this function here, if you do like this function will be executed when Python reads your script. But you don't want that. You want that when you press the button, when the user presses the button, this function is executed. So Tkinter knows that, and if you just pass this like this, Python Tkinter will execute it when the button is pressed. So view command, and now you need a view command function. So let's write our functions just here. The view command. So think about the output now. The output we are getting is a tuple. So I'm going to execute the view function here, so print view, just to see what we have if you have forgotten it. So python backend.py, and so we have a list of tuples, so tuples inside a list. And what we want to do now is to insert each of these tuples, so each of these database rows, as a new row inside the list box. So what we can do is we can iterate through this tuple. So that would be for, let's say, row in backend dot view. So this is actually this list here. So this is actually an object, and a list object. And then list one, I believe that's how our list box is called. So yeah, so it's a list one. That's a variable holding our list box. Dot insert. And then the insert method gets two arguments. The first argument is the index where you want to insert your values. So you have a list box, and that list box has several places. So yeah, it has the first place, and then the second, third, and so on. So if you want to put it in the first place, you do enter 0. If you want to put it in the second, you would enter an index of 1 here, and so on. But think about that. We are iterating through these tuples. So we go to the first tuple, and then we would want to put it, and we would want to put this tuple as the first item of the list. And then we would want the second to be put as the second item, and so on. So in such cases, the insert method also has a special index that is called end. And then you pass the row. So what that means is that the new rows will be put at the end of the list box. So you have this row, and this is put the first one, and then this will be put at the end of the existing rows. So that ensures that every new row is inserted at the end of the list box. So I hope that is clear. And I would actually like to execute the script. So now we have the front end .py, and I have made an error here. So actually I want to import backend here, like that. Execute again, and we got the interface. So let's see what view all has. Name backend is not defined in line 5. So back, yeah, of course it's not defined because I have a typo here. Backend. All right, let's try it again. Close it. Let's see. Great, so we got the rows displayed in the list box. But when you press it again and again and again and again, these rows will be appended to the existing ones. So we need to think about how we can actually have an empty list box when we press the button. That's actually very easy to do. We need to ensure here that when these lines are executed, the list box is already empty. So what we can do is list1 delete and 0 end ensures that you are deleting everything from the index of 0, from the row with index of 0 to the end, to the last row. So let's see how that goes. View all, and if you press view all again, you always get all the rows that you have in the database, in the table. Great. Let's now go ahead and define a similar function for the search entry button. So the button is this one here, search entry. And again, we want the user to enter at least one value in the entries, in the entry boxes, and then they press the search entry button, and then they expect the program to return the rows that contain the entry that the user input in the entry box. So again, you'd want to insert data in the list box. So again, you can just call the search function of the backend script in here, command. So you need a wrapper function. So let's say search command. Another good reason that you want to use these wrapper functions, so to say, is that in some cases, like this one here, you are passing some parameters to the function. So if you look at the backend, and the view function didn't have any parameters, but the search function has some parameters. So that means you're not allowed to put brackets here, so you have to use another function where you call your main backend search function with parameters actually, and that's what we're going to do now. So def search command, and again the search command, what we'll actually get as argument is a title that the user will input, an author name, and year, and ISBN number. Now the way we're going to get these parameters is from the entry widgets. So where's the entry? Here are the entry widgets, and you should remember that we have this string var object here. This variable that has the string var data type will be given as a value the text or the number that the user enters in the entry widget. So keep that in mind. Let's go ahead here, and the first thing you want to do is list1.delete. So you want to empty the list. Alright, and then you need to loop through the backend list output, because in this case, let's execute this quickly. So the backend script. So we are searching for the author name John Smith, backend.py. Alright, we don't have any John Smith at the moment, so let's look for John Smith. So we got an empty list there. Save again, and you'll see that we got a list of tuples. So in this case we have only one tuple, but you get the idea. That means we need to iterate through for row again in backend dot search, and here you need to be careful. So the search function has parameters, and the first parameter will be title text. So the text that the user is inputting in the entry widget, in the text entry widget. However, we are not done, because the title text is actually a string var object, so it's not a plain string. And what we need to do is actually append a get method here, and this will output a string object. So if the user enters John Smooth there in the widget, this will produce a simple John Smooth string. So I hope that makes sense. Author text again, get method. Then we have year text.get, and lastly ISBN text.get. So for a row in the list that the search function will output for us when it searches the database, we simply want to insert new values at the end of the list, just like that. I can see the syntax highlighting is not working here, so I probably have some sort of typo. Yeah, I'm missing a colon here. So now for and in were colored in purple. Okay, so let's try out the front-end script. And let's look for author John Smooth. Well, obviously I press the view all button, so I got everything here. So you want to press search button. Alright, search, and it always shows John Smooth. If you say view all, it shows everything. So it seems to be working. And next is add entry button. So the user presses the add entry button. They expect that the data they have been typing in the 4 entry widgets, this data will be stored in somewhere. They don't know where, but they will be stored somewhere, and they will be able to retrieve them. So that means you need to call the insert function in here in the backend script. So this function will get these 4 arguments, so the values from the entry widgets, and it will post them in the book table. As easy as that. So first thing we might want to do is go to the add entry button. So here, and then add a wrapper function here. Add command, and then we create an add command function. And this is quite straightforward actually. You just say backend.insert, and here you pass these values. So I'll just copy this and paste them here. So let's try this out. Let's try to add some entries. Let's say trees and grass. Let's say Ben Sand, year 1917, and just put a number there for the ISBN and add entry. So the entry has probably been added in the database, but we didn't see anything, and you can see it with a view all function probably. So if I press view all, we'll see trees and grass, but it would be good that when we add entry, the new entry is displayed here so that the user knows that the entry was successfully added to the database. So here is trees and grass. And so let's go ahead and do something that the entry is shown in the list box when the user presses add entry. And what we can do is we first need to ensure that the list is empty. So delete 0 to end and the list, and that gives us an empty list. Then we insert new values at the end of the list. So what values? Well, these ones. So the values that the user will enter, just like that. So let's see how this goes. Let's say lands, grasslands. Let's say Kirk Hammett and year 1910 and a number there. And this is not quite what we were expecting actually, and we got this because we are inserting here many values indeed. So we are telling Python to insert all this in a new value, this in a new one, and this as well, and so on and so forth. So the solution here is simple. Just put it as a single value, so as a tuple, and then run the program again. We have an error here, so we need one more bracket because this bracket here closes here. So just like that. Try it out again. Let's say Wonderland, Gomes 1944 and a number here. Add entry. And now we have the row in one single line. View all, and Wonderlands is there. Grasslands is also there. So let's move on. Okay, we have some more code to go. We have defined the view, the search, and the add buttons. So now we have the delete, the update, and the close button. And I'd like to continue with the delete button, because the delete button is easier to implement than the update button. So let me call the interface again. And again, think about the user. What the user might expect is that they may want to delete one of the rows, let's say this row. So they expect to select this row, and then they press the delete selected button, and this row will disappear from the database. And they may also want to, when they select a row, they may also want to see the data in these entries. And we will take care of that too, so we will fill these entries with the corresponding values when the user clicks one of the rows here. Alright, that makes sense, I believe. And now let's look at the delete function in the backend script. So what delete does is it expects for an ID, the ID of the row, and then this SQL statement then looks for this ID and deletes the entire row of the book table where the ID is equal to this given ID here. So what we need to do is, when the user selects one of the rows in the list box, we need to grab the ID of that row and then send that ID to the delete function of the backend script. And then the delete function takes care of the row. Oh, good. And again, in this case, we would also want to append some sort of delete command function to the to the delete button. But in this case, I would actually like to do a bottom-up approach. So let's first think of how we're gonna get the row selected by the user. So let's think about that first. And you don't know probably, but there is a method called bind of the Tkinter library, and bind is used to bind a function to a widget event. So let me write that bind method so that you understand things better. So we are binding a method here to the list box widget. So it makes sense to write that method after we have defined the list widget. So we define the list widget here, and we configure it, and then list1 dot bind, and the bind method takes two arguments. So it takes the event type, and also it takes the function that you want to bind to the event type. The event type here actually goes inside these characters, and it's called listbox select. And then you want to specify a function here that returns a list object with a selection. So something like this. Actually, we will expect a tuple in this case. A tuple with the ID, the title, the author, and the year, and the ISBN number. So let's call that function get selected row. Okay. And then we go ahead and define that function. Let's define it in the very beginning here. So def get selected row, and this function now, because we have binded to an event, to a widget event, this function gets a special parameter called event, and the event parameter holds the information about the type of the event. So Python knows that when you pass this to the bind method, it expects the function to have this event parameter. And then, so again, this function will return the tuple, the selected tuple. But first of all, the way this works is that we first need to get the index of the list from the list box. You know, the list may have, let's say, 10 rows, and the first row will have an index of 0, the second an index of 1, and so on, up to 9 if we have 10 rows. So to get the index of the selected row of the list box, we refer to the list box and then to the selection method of the list box. Alright, and I'd actually like to just make a temporary return of the index here so that you see what this object is and how it looks like. So let's hope this will work. It should work. Python front end, yep. And so view all. Actually, we should have printed out the index here. We are just returning it, so print index, and let's try this out again. So I expect to print out the index here. Yep. So this is the index of the selected row. So this is row 1, sorry, 0, with index 0, 1, 2, and so on. However, as you see, this is not a plain number. This is actually a tuple with one item. So what we need to do is a very simple trick, and we just grab the item with index 0 of the tuple, which is number 2 in this case, 0 in this case, and so on. And then we might try this again. View all, and now we get single numbers. Great. So we're very close, but not there yet, because we need to get the actual tuple with all the values of the row. And to get that, you need to apply another method called get. So let's say the selected tuple, so the actual tuple that we want, the actual row that we want, is equal to list1.get index. So you can read it like this. From the list box, get the tuple with index x, and then we can try this out. So what are we getting here? And don't get confused with this row. This is being printed out because in the backend script we actually have a search function being printed out. So this is printing the output of the search function. So this function is saying, give me the row with John Smith as author name. And next time this will not be executed. So back, what we want to do is select a row, and we get the row printed out there as a tuple. So that's great. So what's next? Well, next is we need to pass the ID of the selected tuple to the delete function of the backend script. We go to the delete selected button, command equals delete command. That's how I'm gonna call the script, and that should go here, def delete command. And what we have here is backend dot delete, and again the delete method gets as argument the ID. So we have a tuple called get selected row, so we need to return the selected tuple. So if we call the function now, get selected row, and we need the item with index 0 from a get selected row. So save the script, and we got an error at line 24. I don't have the colon here. Try out again. View, and let's try to delete the moon. Delete. And Python is saying that the get selected row is missing one required positional argument. and that's the event argument. And so Python is right because here we have an event parameter, so we need to pass that as an argument. But here we are calling the function without any argument, so we're getting an error. On the other hand, we cannot remove this event because this function is also being executed by the bind method. So in that case, the hero of the day here would be a global variable. So you might already know that local variables, like the selected tuple, is a local variable because it's defined inside a function. So if you print this tuple outside the function, selected tuple, you will get an error because Python will say, oh sorry, I don't recognize this, this is an undefined object, because local variables make sense only inside the function. So in that case, we can use global variables. And the way to create a global variable is by using the global keyword and then declaring the name of the variable that you want to create. So in that case, if you print out the selected tuple outside the function, you get the value of the selected tuple. And the value of the selected tuple in this case would be the tuple with the values of the row. So in that case, we don't need to return the selected tuple because we can simply point to the selected tuple variable in that case. And we need to fix our delete function here. So we want selected tuple, and we want the item with index 0 from the selected tuple. So let's execute again and view all, and let's delete the moon, delete selected, view all, and the moon is gone. So it seems to be working. Now I would also want to fill the entries with a selected tuple or row, if you like. So we need to use the insert function of the enter widget, and we could actually write those methods inside the getSelectedRow function, because you know, when the user clicks one of the rows, when they select one of the rows, we immediately want to fill those entries with values. And the first would be the title end, and we want to make sure the entry is empty. So delete 0 to end. Delete everything from the entry if there is something. And then E1 insert. So what we want to insert in the author entry, well, that would be the selected tuple with an index of 1. So the ID has an index of 0. The title has an index of 1. And this would be the same for the other entries as well. So we have E1, E2, E3, and E4. And then here we want to grab the author name. Here we want the year and the ISBN number in here. Great, so I hope this will work. It should work. So view all, select something, and insert method is missing one required argument. I think I forgot to put where I want to insert the new values. So we need end here, 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 and here. So let's see again, view all, and now it seems to be working. So trees and grass and bandstand and so on. And let me try to delete this. Delete, view all, and the entry is gone. Great, so now let's go ahead, without wasting any time, let's go ahead and implement the update function. So back to our backend script, the update function gets an ID and title, author, year, and ISBN. So unlike the delete function, which only got one item, this gets 4 items, 5 items actually. So in the delete command function, we pass the selected tuple with an index of 0. Now the update function will be similar structure, but then we will have multiple arguments here. So we have ID, title, author, year, and ISBN. So selected tuple with an index of 1, selected tuple with an index of 2, selected tuple with an index of 3, and selected tuple with an index of 4. And then we need to add that function to the update button. So update command. All right, and I forgot to change this. Update command. This should work, so let's see. I've forgotten to pass the name of the parameter here. So command equals update command. Save and execute again. And view all. Let's try to update this row. So let's say 9. And you press update selected. And yet another error. Don't get scared about errors. The more errors you see, the more familiar you become with Python. It's important to focus on the error, so see what line you're getting the error and try to understand the type of the error and the message you're getting. So in this case, this says delete takes 1 positional argument, but 5 were given. Oh, we didn't execute the delete function here. We executed the update button, which gets an update command function. And you go to the update command. So the update command, backend delete. So that's why we are getting this error. The update command is actually executing the delete method of the backend script. So we want update instead of delete. And save the script and execute again. View all. I want to really update this number here. So 9. Update selected. View all. And it's not working. And in this case, we're not even getting an error here, so you may feel lost at the moment. So what you could do in this case is check what you are returning in your update command function. So you know that you can isolate problems by using print statements. So let's say you want to check what you are sending to the update function. I know the problem here, but just to show you the way you can troubleshoot things. So print out and execute this again. View all, get these grasslands, update selected, and you see that the tuple is being printed out as it is. So this number is not changing. Actually, I didn't change it, so let me change this again. Let's say 24 and update selected, and so you see that the number 24 is not being printed out here. So that means we are sending to the database this record again, so we're not sending the updated record. So why is that? If you have already found it from earlier when I wrote this function, that's very great. If you haven't, well, the reason is that we are sending to the update method the selected tuple. And the selected tuple is the one that the user has selected. So it's not the actual entries that the user is sending to the update command. So in that case, we actually want to send out these values. So the current values of the entries. So I'll copy this and paste it just here. Okay, and the first selected tuple is the ID, so we want to keep the ID of a selected row because the user is changing the other values, not the ID. And this looks fine. The bracket closes here. Save. So delete this one. Save. Execute again. View all. Go to this and let's say 3. Update selected. View all, and 3 is there. Delete. View all. It goes away. You can add it again because you have it in your entries. Add entry. And it was added again. And you can see it here. So everything is working great. And we want to close this program, but the close button is not working at the moment, so let's go ahead and implement that as well. And that's very straightforward. You just go here and command equals to. So you want to destroy the window, right? So window dot destroy. That's it. Save the script. Try it out. So these are working as usual. Close, and the window closes. And you may also want to put a title to your window. And use the WM title method of the window object. Title, let's say book store. And you should see that name in the title bar. So finally we are done with this program, and I know there might be things to improve, and I would welcome any suggestions from you so that we could improve the program. Programs have versions, so this is version 0, you could say. And I hope you found this very useful and learned a lot from this. So I'll talk to you later. Hi again. So we have this great program that works very well. And it consists of 3 files, so 2 Python files and 1 .db file, where the data is stored. And this is good. We can execute the scripts like this, so using Python, and we get the program displayed. But think of if you want to give your program to someone else, you can just tell them, oh, install Python, and you can execute the program by going to the terminal and invoking Python and the script. So that may get terribly difficult for users who are not experienced with programming. So in that case, you want to make a standalone executable program that you can just send to anyone, and they can just double click it and go ahead and insert data and retrieve data and so on. So in this lecture I'll show you how to make an executable file, and you will make that file whether you are on a Mac or Windows or Linux. So the code is the same. And there exists a great library to make standalone executables. That is the PyInstaller. So you can install PyInstaller using pip. And now it's terribly easy to make a standalone executable file out of your Python scripts. All you have to do is call PyInstaller and then point to your script. So in this case our main script is frontend.py. So that's the script that is holding all the code, and it also imports the backend script. So we want to point to that file. And if you leave it like this, you'll get a .exe file if you are on Windows, a .app file if you are on a Mac, and together with those files you'll also get a bunch of other files that are associated with your program. The benefit of that is that it gets easier to troubleshoot any errors that you may get. So you have lots of files, and then you can go to those files and find the error and so on. But if you want to be practical, you'd want to pass a parameter here called1 file. So that will create a single executable file for you. And in this form, you'll also get a terminal, a command line displayed on the background of your graphical user interface. So if you don't want that, you can specify another parameter called windowed. So like that, and execute. And you'll have to wait a while. And my executable was created. So if you were on a Mac, this would be a .app file. So mine is here the dist folder. So in this folder, I can look up here. So frontend.exe. If you execute that, you'll get the window. And as you see, you also got the books.db file generated. So by default, this only creates the executable file. Then when you execute the program for the first time, remember that we had a connect function in the backend script. So that function creates a database. So that's what this did. And if you view all now, you don't have any rows, so you don't have any data because this was created from scratch. So in case you want to have the existing database, you'd want to give to your user both the executable file and the existing database that you have. So for instance, let's say this doesn't exist, and I can go to my existing database, and if I put it here, so Python knows where to search for the database. Now if you view all, you'll get the data from the existing database. And we can make a quick test. Let's add the book, the great shirt, the tailor, and year 1913, and put a number there. Add the entry, and the entry is added to the database. And you can close the program, and that's it. Hope you enjoyed this, and I'll see you in the next lecture. Hi, and welcome to this new section where you learn about object-oriented programming, often referred to as OOP for short. Now, if you have experience with programming, that's probably a familiar concept for you because OOP is used in most of the languages. But I assume you don't know anything about object-oriented programming, so I'll explain the concept from the beginning. Now, there are various definitions of OOP out there, and some get very tricky. But I believe the best one to know is that object-oriented programming is just a way to organize your code. That means OOP is not a must. So you can simply use functions to build an application, as we did here with our bookstore application. And many programmers choose to not use object-oriented programming to organize their code, so they don't use the OOP way to write their code, in other words. However, it is generally accepted that if you have more than two functions which apply operations to the same object, for instance a program that applies operations to a Tkinter interface, so you have these callback functions, and so you should organize these functions into something called a class. Now, because object-oriented programming is a complex concept, I didn't include that in the beginning of this course. So I wanted that you first build some applications using functions, which is more intuitive, and then you move to object-oriented programming. So back to our graphical user interface application. So the object here, I'm talking about objects, and the object here is the entire window with buttons and other widgets as well. Now we can put all the attributes that define this object, so this window, such as the title, the buttons, the labels, and also the callback functions attached to this object inside a class. So in our application we didn't use classes, we use functions. So this script here does not apply to object-oriented programming. And putting this object inside a class means we're organizing the code in a class, which creates an object, so that's why we call it object-oriented programming. And using classes to organize your code is referred to as object-oriented programming. And what I'll do next is, in my backend script where I have the database operations, I'll transform this script by putting this inside a class. And after that you can do the same for the front-end interface so that you practice object-oriented programming. Now, my purpose here is not to train you how to write classes. I first want you to understand classes, and many learning resources explain object-oriented programming by saying something like, we create a class that creates a dog object, and the dog can eat and bark and so on. Now, that's a good example to train you to learn the syntax of a class, but hey, what is a dog in programming? I mean, you can scratch your head the whole day trying to come up with a scenario where you'd have a dog as an object in your application. So that's still a good example, but only if you have some years of experience in programming and you can quickly think of where and when to use classes based on such examples. I assume you don't have this years of experience, so I'll use real programming objects in this section to explain such a tricky concept as object-oriented programming. So the best way to understand OOP is to first build a program with the known object-oriented programming approach, so using functions. And once you know that program well, then you build that program again using OOP, and then you automatically understand what OOP is by looking at how things are different. So let me organize this code using classes now, and later we'll build a simpler program from scratch where we create a bank account object with Python, and we will apply functions to that object such as withdraw, deposit, and so on. That's great, and yep, that's about this introduction, and let's move on to the next lecture and write some classes. Good, now I'll go ahead and transform this script into an object-oriented programming style. So in other words, I'll organize these functions in a more efficient way. And just to refresh your memory, what this script does, so we have a backend and front-end script, and the front-end, what it does is it constructs the graphical user interface, so you know that. And we have this books.db database file, and there are some data there, and you can search for entries, so for rows in the database, add new, and so on. And this frontend.py constructs the graphical user interface, and this backend is responsible for the database interaction. And so object-oriented programming is about encapsulating functions inside a class. So class, and let's call this database. And yeah, that's it basically. We still have a lot of things to do, but let's think about what is this database class. Well, whenever you decide to use object-oriented programming, you first need to think about the object that you want to use, which is the object that you want to apply these methods to. And in our case, that would be the database. And so then we insert data to the tables of this database and view data and so on. Now this object, you first need to create a minimal object when you call the class. And I'll show you how you call a class in a minute. But for now, let's focus on creating the blueprint of the object. So you create the blueprint of the object, which is this one here. And then you create object instances using that blueprint. And you do that by calling the class. Now, when you call the class, you want to have this minimal object. So in this case, that would be to establish a connection to this database, and then create a cursor object and maybe check for a table so that you make sure that your database has a table. so that it allows you to later apply methods to this table of the database. Otherwise, the database would be useless. So it needs to have a table and an established connection. That means you have to figure out a way that when you call the class, these lines here are executed. And Python has reserved a special syntax for that. So the first function of your script, you need to call it init with a double underscore in front and on the back. So that's an init function, which means initialize an object. In other programming languages, that is called a constructor, so it constructs the object. So when you call a class, this function is executed, but not the other ones. The other ones are executed if you refer to them. Like in this case, that would be something like a database dot insert, and then you pass the parameters, the arguments there. Now we have quite a few things to add here in the script for this to work, but I would prefer to do this on a trial and error basis. So we execute it, we'll see what error we get so that you understand how things are working there. So what I'll do, I'll call this class as it is now. So we don't need this function is gone now because I replaced that with init. So you don't call functions anymore like we did here. So for instance, here we are calling functions from the backend module, so which is like a module. You are importing this as a module, and in this case now what we do is from backend import database. So we import the database class from the backend script. So that makes available the database class for us, so the database blueprint. So this is just a blueprint. Now we need to create an object out of this blueprint. So let's call that object database. That would be equal to database, so the class. And for now, let's not pass any arguments there. And then we need to replace these references, so we don't do backend anymore, we do database.view. So we are referring to the view function of the database object, which is an instance of this class. Great. So I'll go ahead and replace these other ones with database. So backend, replace that, replace. Yeah, that's it. This is the script name, and it should be like that. Escape here. Great. Now I'll go ahead and execute that. So don't expect this to work, but we have to look closely to the error, trying to understand what it says. So traceback file frontend.py line 4 here. So init takes 0 positional arguments, but 1 was given. And what's happening here now is that when you call the class, this class will create an object instance and store it in this variable, and then it sends this object instance to this function. So let me split this on the right so that we have both the scripts in here, so the front end and the back end. So basically this database object instance is being sent to this init object, even though this is an empty bracket. So that's like a hidden syntax there. And to fix this, you need to perform a trick here. So it says init takes 0 positional arguments because it has an empty bracket here, so it's like a normal function. And functions, if you don't put a parameter there, but then you pass a parameter when you call it, the function will say, I don't take any positional arguments or any mandatory arguments, but 1 argument was given to me, so I'll throw an error. Now to fix that, you need to pass a parameter there, and everyone passes self there. So you can pass any word that will still work, but as a convention, so that your code is readable by other people, you need to pass self. So now your init function takes a parameter, and when you call this class will send the object instance, and that object instance will go inside this parameter. So this parameter will be replaced by the object instance argument. Great. If you still don't understand that, I'm sure you'll do so later as you write more classes. Good. Now I'll go ahead and save this and try out the script again. And great, so that means that the class was successfully initialized and it created an object instance for us. Now let me close this and maybe add something there. This is not necessary, but just to show you that if you want to add more parameters to your init function, you do something like db and then replace this with db, and then here you pass the argument that will be passed to this db parameter. So that would be books.db, the file path to our database. Great, and if you execute this again, you get the same result. So what's happening here is that Python is first sending the database object instance and to the self parameter, and then it sends the path of the file to the db parameter, and that db parameter sends that file path to the db parameter of the connect method. Great, now let's see how these methods will work. So we have the view all button, which if we press it, what will happen is the view function of the database class, actually the view method of the database class will be executed. So this one here, let's see if we are able to get it. Well, an error. Let me close this. So it says view takes 0 positional arguments, but 1 was given. So that again suggests that when you call a method of a class, the class is sending the object instance to that method as well, just as it did with the init function. That means we need to do the trick again. So just pass self there, and yeah, try out again. See what error we get this time. Well, no error, things are working, obviously. So that's great. However, if you try the other methods now, like insert, you'll probably get an error. So let me try that. So view all is working fine, but if we insert something, let's say hey there, and yep, add entry. So insert takes 4 positional arguments, but 5 were given. So insert, and these values are being passed to these parameters, but also we're passing the object instance. So let's go ahead and self there, and I'll do the same for search as well. Delete and update, and yeah, that's what we have. Looks good. And let's try out again. So view all and add entry, and yeah, this seems like it's working. View all, and here we have hey there. Close. So we were able to create a class and put all the functions inside that class. So we have an organized program now. And so that's object-oriented programming, but object-oriented programming is not simply about putting some functions inside a class. Object-oriented programming is about good design. So this script is not probably the best design that we can come up with. Why is that? Because we're not making use of the real advantages that we have by using classes. So what I mean is that here we are creating these methods, and in each method we're executing some close functions, and also creating a connection in each of the methods. So we can reduce this code furthermore by removing the repeated actions. So in a class, what you need to think about is a way of constructing something at first, so in the init function, and then you refer to that something in the other functions, in the other methods. So we're talking about methods here. So even though our script is working fine, in the next lecture we will go ahead and improve the design of it. So I'll see you there. Good, we were able to transform our script, which was built using functions, and we created a class and put those functions inside that class, so they are now called methods. And while this is a use of a class, it's still not the best use of object-oriented programming paradigm, because we have a database here, a database object that is being created, but we are not treating it as a solid object. So we are opening it and closing it in every method. So what I'm thinking is, we create a connection when we call the class, so when this function is executed, we create a connection there and we keep that connection opened. So I don't include this close method there, but I'll leave the commit method in case there is no table, and a table will be created and the changes will be committed to the open connection. Now, because we have a connection open there, we don't need to establish a new one in each method. And we don't even need to create a cursor object, because the cursor object is being created in here. So we get rid of those two lines in every single method. So in view, we have a cursor object when we go here, and then we execute this statement to that cursor object, so that is good. Then we go down here, these two as well, and for the delete method, and update as well. Great. Now let's see how this goes. Let me make this closer. So we call the front-end script where we are creating an instance of our object. So far so good. View all. And it says that name cur is not defined in line 17. So we executed the view method, and what the view method does is it tries to find a variable, a declared variable inside the function. So the cur variable, it doesn't find it, so then it looks if there is a variable outside the function, and it doesn't find it. Actually, there is a variable that has been declared in this init function, but this is a local variable. So this has value only inside this function. So you cannot access this outside of the init function. But if we refer to the self argument, which is the database object, and see what we get. Let me close this. Save. That works, and view all, and now we get another type of error, and it says attribute error. So let me close this. So look carefully here, and it says a database object has no attribute cur, and that's in line 17, so this one here. And the database object, this one is this one here. So self has been replaced by database, which is the object created by this class, and this is an attribute of this object. And to fix that, we need to create an attribute there. So we say self.cursor equals to connection.cursor, so the cursor method of the connection object of the SQLite 3 library. Now if we try again the code, it says name cur is not defined in line 8. So now that we created an attribute, this is trying to find the variable cur, so the local variable cur, which is not in this function, because now this is an attribute of the class. So that means we need to refer to self here as well, so to the object, and then cur execute and so on. So if we try this now, we get another line, cur is not defined in line 18. So here, that means you need to do the same, and we don't have any cur variable anymore. We have the cur attribute. So now if I run this again, I'll get probably an error about the connection this time. The con variable. Con is not defined in line 19. So again, this view function is trying to find the variable connection, so self commit there and here as well. So you declare the attribute there, and there you commit the changes down here, and self connection close. So that looks good now. Rows equals to this, so rows is just a local variable that is created here, and then we return the fetched rows from this expression. So this method returns this when it is being called in this script just here. Good. And yeah, let me try what we have at this point. Line 7, name con is not defined. Oh yeah, we need to do the same for these two, and everything looks good now. So let's try again. Yeah, view all, and now we get the data there. But when I press it for the second time, we get yet another error. And so it says cannot operate on a closed database. So why is that? Well, I pressed the view button once, and this method was executed, so the cursor object was able to fetch this data, and then we closed the connection and returned the rows. So we were able to get those 3 rows there. But then when I press the view button for a second time, the view method faces a closed connection. So that's why you get this cannot operate on a closed database error. So, and see what we get. So view all, it's working well. Yep. That means we can go ahead and modify the other methods. So self cursor and self connection, and remove this close. Let's think about closing the connection later on. So don't focus on that now. Just try to make these methods work. Self here, self there, and there. Again for the delete method, and yep, remove the connection close. And everything should work fine at this point. So let's see, view all. Yeah, this is working. Let's search for something. Let's see, and search entry. Oh, we got one cursor there. So cur is not defined in search. Oh yeah. Sorry. Okay, again. You all. Let's see, search entry. And yet another name error. Name rows is not defined. Oh, so by mistake I converted this local variable to an attribute. So rows here, rows there. Okay, one more time. The all. And now it seems to be working. So let's add some data. Add entry there, and cannot operate on a closed database. Oh, why? because in the search method we have a closed database, so we close the database there, and I overlooked that, so we don't have any more closed methods there, no. So let's try one more time then. Sorry about that. Add entry, and now it seems to be working fine. Great. So everything looks good, except of we don't have the close method anymore, because we can't keep that method in the methods of our class, because you saw that when we have that method there and we end up with this error. Or you can leave the code without a closed method, but you'd end up with some problems later, because if you have some methods that have not been committed, then when another program connects to your database, and then this data will be committed with the next operation, so it messes some things up sometimes. So as a rule, you should close the connection. And to do that, there is another special method that you can add to your class, like this one here, but this other one is for destructing your object, and that is called del. So for delete. And this also gets the object instance as a parameter. So this method is applied, is executed when you call an instance of the class, like we're doing in the front-end script, just here. While this one here, this is executed when this instance is deleted from the script, which happens to be when the script is exited. So before the script exits, this method will be executed. And what we want to do here is self.connection.close. So that should do the trick. Now if we try out this, we should get the same results. So I added this by mistake, but anyway, so let's see, you can search for that and you get the rows with that particular value. So this is my solution, and there's no standard way to write a script, so there may be other alternatives to solve this problem, so to build this application. So you may also choose to add a method there or here in the graphical user interface. So you could do something like you add a button, like commit button, and then here you add another method called commit, and then you remove probably all these commit methods from these methods, from the methods of your SQLite operations, and then you put that method, so one method commit, inside that commit method of your class. So when the user presses commit, then you commit the changes to the database. So that would be another solution, but this is what we came up with in this particular case. So I hope you understand a few things now. And this is rarely used, so normally you only have to use init and then the other methods. But this is appropriate when you want to apply something just before exiting the program. So that's great, and in the next lecture I will write another class. So we will think about how to model a problem which is about creating some sort of bank account object where we store a balance of money. Then we withdraw and deposit money to this balance. Now, as an exercise, you can convert this script, so the Tkinter part of the program, the front end, into an object-oriented form. So you put this inside a class and try to come up with a good solution. I'll also provide you a solution to this, but before that I'd like you to try out yourself, so you practice object-oriented programming a little bit. Yeah, that's good. With that, I'll see you in the next lecture. Well, in the previous lectures I mentioned that I'll be creating a program, an application, where we'll be handling a sort of bank account. So that will have a balance, and then we'll be applying some operations such as withdraw money from this bank account object and deposit money as well. And we'll be storing the value, so the balance, in a simple text file. So that's not one of the 10 programs we're building in the course. This is just to get you familiar with classes and to explain them a little bit more. So I'll do some housekeeping here. So let me create a folder here and put all these existing files in this folder. So we have the previous files in here, and I'll create a new folder now. Let's call this account, and in this folder I'll have my Python script. So let's call it like this. So under account we have this Python file, and we also need this text file where we'll be saving the current balance of our bank account. So this will be a trivial application, because in real life you don't want to save the bank account information, the balance, in a text file. In real life you'd want to save that in a real database, such as PostgreSQL for instance. But for the sake of practicing object-oriented programming, we will just save the balance value in this file. So this is our storage. And also for the sake of simplicity, we'll be working only on one single account. So our program will be able to process one account object. Because if you have multiple accounts, then the solution could be different from this. So you'd probably have to think about having a table, and maybe a database would be necessary here. So let's think about our personal account. You could use this program for your personal notes, so you may want to keep track of your balance, and you can use this Python program. And now, the object here is the bank account. And now this object, we should start thinking about what attributes this bank account object should have as an initial state. So we talked about this minimal object. And a bank account would have, of course, an initial balance. So let's start to create this account object and call it account. You can call it whatever you want, but I'll call it account. So init is the first function we want to define, and we pass self in there. And yeah, let's keep it like that for a moment. And we said our bank account object will have a balance attribute. And in our case, we have this balance.txt, and let's create an initial value there. And now, to create an object instance, we need to grab this value and pass it to our init function, so that we construct this minimal object. And because we have a file, what we need to do is we need to read this number from this file, and naturally what you'd want to pass here is some parameter like file path. So this is how I'm going to call that. And now, if you remember, in the bookstore application, in the backend script, here we also pass a parameter to the init function, and then we created a connection object out of this database file. In this particular case, what we want to create is an integer, so a number out of this file, out of this file path. So you could do something like with open, so we're doing file handling with the with method, with open file path, and this is a text file, so we need to go with R mode, which means to read. So we're opening the file path, this file in read mode as a file. So this is just a temporary variable that exists in this with statement, and then we need to read from this file. So something like file.read, Yeah, that's it. This will read the file, but you're not storing that anywhere. So what you want to do is say self and balance equals to file.read. So what that will do, it will save the value inside the text file in this instance variable. So this is an instance variable. That is how it's called. Actually, this is the instance variable and this is the object. So the account object. Good, and this is almost good. And we also need to add the integer function there, because this will be read as a string by default, so we need to convert that value to an integer. And yeah, that should work, and that should construct the object for us, the account object, with a balance attached to it. And before going and creating the like a withdraw method here and then a deposit method, I'll prefer to call an instance of this class first. So I'll do that here. Let's say store that in the account variable. So this will be the object that will be created out of this blueprint, the account blueprint. And there you need to pass this argument, the argument for this parameter, which is balance.txt. Great. And for self, Python will automatically pass the account object instance. Good. Now this will create an object instance, and let me print out that object here. So we see some output in action. Python, and that's inside the account folder, and ack.py. We got an error, no such file or directory for balance.txt, and the reason to that is that we need to pass the account directory there as well. So, and yeah, this time it's working. So we had to pass the directory there because we are in this folder, in the demo folder, and you need to pass the account folder first and then point to the balance.txt. And this is the output. So it says main.account object. So the account object of the main module. And what main is when you execute a script like we did here, so you point to the script with Python, Python will assign this name to the module. So this module will get this name, and the script actually, but it's treated as a module. But if you import that module, so if I ran, I open an interactive shell now. So from the account folder, import ack. What happens is that you get the print function executed as well, but this time when you import a file, so when you don't execute it like we did previously with Python account ack.py, when you import the module gets the name of the script that it is written to. So in this case it's ack without the extension. And here you also get the name of the package of the module. So packages are made of modules, and a package is like a folder, and there you have several modules or one module like we have in this case. And our package here is account. So account, and then it has this module, and then this module has this class, the account class. So that was something I wanted to show you. Packages, modules, and classes. Great, now I'll exit this Python shell and play around with this script a little bit. And what we did here, we printed out the object namespace, and we didn't get the actual balance as an output because we are not returning the balance here. But if you want to get a balance, you'd want to point to the balance, and that uses a dot notation to point to the object that holds the balance attribute. So let's see what we get this time. And yeah, 1000. So that's the current balance. as you can see, you are able to access attributes of your object instance using the dot notation. Good. Now let's add these other methods there. And what can we do to a bank account? Well, we can withdraw money. And you always need to pass self in all of your methods, and then the parameter that applies to that particular method. In this case, when you withdraw some money, well, you have an amount in mind that you want to withdraw, so you pass amount there as a parameter. Now, just to be clear that you understand what I'm doing, here is I have an initial balance that is being read from this file, so for this text file, and then I want to allow the user to apply operations, so withdraw money from this balance. And once the user executes the withdraw method, I want to update the balance number inside the object instance. And I don't want yet to write that balance to my balance file. So I just want to calculate something here, like self balance equals to self balance. Well, this is a withdraw, so minus the amount that I want to withdraw. That means this will do self balance equals to 1000 minus 100, let's say, and I'll end up with an updated balance of 900 in this case. And then if I want, I can go ahead and open that file again here, and then write this updated balance in that file. So that would be one solution, but a more constructive solution would probably be to have a specific method that commits the changes to the file. So you may want to withdraw some money, and then you deposit some money inside the same session, and then you apply the commit method to save the changes. So this is the solution I want to go for. And yeah, we are done with the withdraw method. Now deposit self and amount again. So this is a local variable, this is a local variable. They happen to have the same name, but they don't have to do much with each other. And self balance equals to self balance plus the amount in this case. So let's see what we have this for. And I'll keep this instance object here that is being generated. So we are instantiating an object instance, in other words, and print out the current balance. And then I want to withdraw some money from my account object. That means I apply withdraw to the account object, and withdraw takes 2 arguments. So the object instance, which is passed automatically, and then the amount, which could be 100. And once I do that, I want to print out the updated balance. So let's see what it's gonna do. Yeah, 1000. So an object instance is created, and you get 1000 printed out, because here you have 1000, and then you take 100 out of that, and so you end up with 900. Great. So if you run that again, you will notice that a new object instance is being created again. So you don't have 900 as the current balance anymore, you have 1000. So that means you need to write the changes to the file if you wanted to save those that balance. And we can do that using a method, and let's call it commit, and pass self there. And I don't think of any parameter that I need to pass to this commit method, because we will work with are the existing variables there. So this would be something like with open. Well, we need to open the file path, but we have a small problem in here, because the file path variable now is just a local variable in this init method. So if we pass it here, this function, this method will not recognize it. So this is a bit different from the other, the backend script that we wrote, because here we had this parameter like we do in here, but in this case this parameter, it was only used inside the init method, so we didn't use it anywhere else. So there is a solution to that. One solution would be to go ahead and pass another, let's call this path here, so another parameter to the commit method. Then when we call the commit method like we were doing with withdraw, we'd have to pass the balance.txt, actually this path, to the commit method. While that would work, it's still not the best practice of object-oriented paradigm. So we need to seek for another solution. And that would be to make this local variable an instance variable. And to do that, you'd do something like self and file path equals to file path. And what this does is, so file path, don't confuse this with this. This happens to be the same, but you can also write another thing here, like anything. So this is the parameter of the init function. So the balance.txt will go to this parameter. So the path of this file will go to this parameter. And then you create this instance variable. And that instance variable will be equal to this path. But you can use this thing here, you can use it wherever you like inside your class. And in our case, we would like to use it in here. So we open the self.file path in the right method this time, because this time we need to write, or to overwrite, in more accurately, to overwrite the current balance, which should be this one, for example. We want to overwrite that to this file. So as file, this is just a temporary variable file, and file.write and self.balance. Good, let's try this out. And we didn't get any update in the file here because I forgot to actually call the commit method. And so once we withdraw money, let's print that out in the console. And then account.commit without passing any argument explicitly, because implicitly we are passing the object instance. Good. Let's see what we get this time. And we got an error there, invalid literal for integer with base 10. So this would be the integer in line 6 here. The value that is being read by this method is not converting to an integer. And the reason is that this value has disappeared from balance.txt. And this is reading an empty string, so this is an empty string that is being read from this file, and then you try to convert that and it doesn't work. Now the reason that we got this empty string, empty file here is when we got the previous error. So here right argument must be string, not integer. So what Python did was it opened the file with the method, but then it wasn't able to actually write a value inside that file, so the file ended up empty. So let me write the initial value there, and then now we should be able to run that again. And yeah, now we have the updated value. So again, what we did is we created the object instance, and then we printed in the current balance, which was read from this file, which was 1000 at the beginning, and then we withdrew 1000, so the balance was updated. and then we commit those changes to this file, so we get 900 there. Now same thing if you want to add, let's say 200 and deposit. Let's see if this will work. Yeah, this was printed out. Let's check the file. Yeah, so this is our new balance. And yeah, I hope this clarifies a few concepts about object-oriented programming. If you are creative, you can go ahead and expand this script so you can add more methods there and maybe make this more of a real-life application. So great, and this is about this lecture, and in the next lecture I'll talk about inheritance, and we'll be expanding this script by applying inheritance in there. So talk to you in the next lecture. Awesome, we're almost done with classes, but there's one last concept that I need you to know, and that is inheritance. Inheritance is the process of creating a new class out of a base class. So a new class that has all the properties and the methods of a base class, but also it has some other methods. So why do we do that? Well, I'll explain that to you through our example. So here we have this blueprint, so this class, and let me delete this, not to confuse you. So there we were just calling the class instances. So we have this class which creates a bank account object for us. Then we can withdraw and deposit money from this bank account. Now, what if we want to transfer money from this bank account? So from our bank account, transfer money to another bank account. Well, we would have to add a transfer method in here. And then do something like, just simple, like self-balance equals to self-balance minus the amount. So we pass a transfer amount there, and that is subtracted from our balance here. But as far as I know, you cannot transfer money from your saving account. You can transfer money from your checking account, but not from a saving account. So that method wouldn't make sense for a checking account. And this account is a general bank account. So what we could do is maybe we could create another class, like we could copy this and create another class and call it something else. And so we have all these methods there. So that's one solution. The other solution is to use inheritance. So here is where inheritance comes in handy. You derive a class out of a base class, which is a more general class, like this account class in here. So let's create a new class. This new class is referred to as a subclass, and this will be the base class. So again, you need to use the same syntax. So you use a class keyword there to create a class. And let's call this checking. So for a checking account. The first thing we want to do is to create an init method. With that init method, we will create like this minimal object that I have been talking about. Like in our base class, we also need a balance from our file. And so we need that file path. But instead of writing this code again, as I said, what you can do is, well, first you need to create an init function method. And of course pass self in there, so you always pass the self parameter, whether that is a base class or a subclass. And then in this init method you want to call the init method of your account class, which means that when you create an object instance of your checking class, this method will be executed. And when this method is executed, this method executes the init function of your account method so that you create this minimal object, which is the same as this one here, but then we will have some extra methods down here. So a checking account is this plus some other things. And here you need to pass self and the other parameter that is necessary for this init function. So here we are passing 2 parameters, and we should do the same in here. And if I execute this now, I'll get an error. So by intention, I want you to see what error we get. So let me create an instance of this function. So checking. And yeah, let's try that out. Here. Yeah. That's inside the account folder. So here, and then .py. Let's see. So the first thing that this is saying is file path is not defined in line 21, which is this one here. And the reason to that is that we haven't defined any file path inside this function. So you can pass that inside the init brackets as a parameter, and then you need to pass that here as well. So let's say count balance.txt. Good. And we don't see any output there because we are not printing anything out. But what happened basically is that an object instance was created, and this method was called, and this class was initialized as well. Now, if we try to do, so the whole point of inheritance is to do something like checking, so to access methods of the base class without writing those methods in your subclass. So let's say checking.deposit, and let's put an amount there. So 10. Now if we execute that, we get this attribute error which says checking object has no attribute deposit, so this is not recognizing this method. And the reason to that is that we haven't yet satisfied the syntax of inheritance. And so the key here is to pass an argument to our checking subclass, and that argument is the base class. So the name of the base class. Save that. If you do the same now, and maybe print out the output to see what's happening. So self.balance. Sorry, I meant to say checking.balance. Sorry about that. And yeah. Now it seems to be working. So this method was recognized, and what this did is from 1100, which was the initial balance, it went up to 1110. So this printed out the balance instance variable of the base class. So that's how we deposit some money in our checking account. Now we want to transfer money. So we need to define a new method here. Let's call this transfer self there, and also a local variable amount, so as a parameter. So this is just a local variable, it doesn't have to do with these ones here. And then we want to update the balance. So we want to transfer some money to some account. That amount will be subtracted from our balance. So that means self balance equal to self balance and minus amount. And now if we try that new method there, so we are at this point. Let's transfer 110. Yeah. And I was expecting to have 1100 here, but I got this number, and the reason to that is because we didn't commit the changes earlier when we deposited some money. So when we executed the script now, an object instance was created from the beginning, and it got this number here, which wasn't updated to this because we didn't commit the changes earlier, but you get the idea. So from this balance, subtracting this one here, we get this. That means the transfer method is working. but we just need to apply the commit method there. So again, we can commit those changes. Yeah, let's see what we get now. So from 1100 I want to transfer 100, and now I expect to have this updated to 1000. Let's see. Yeah, 1000 printed out here and 1000 in here too. So that is working great. Also, another thing I want you to know about the inheritance is that you can add your own instance variables for your subclass. Like in this case, our only instance variable is balance, which has been inherited from the account base class, but we can add our own instance variables. So let's suppose this transfer also comes with some fee. So when you do a transfer, your bank charges you some money, and you want to give that fee as a parameter. So let's keep things simple and say when you transfer money, so balance minus amount minus the fee. So let's not apply percentages there. Let's suppose we have a fee of $1 per transfer. Now if we apply the transfer method again, we'll probably get an error because this fee is just a local variable here. So what you need to apply now is you need to transform this fee to an instance variable, which is self.fee equals to fee. And that means if you pass now a fee here, so let's say $1 or any other currency, and you pass it here, so this will go here and that will go here, and this will be equal to the fee that you're passing here. And then we can make use of this instance variable and use it in this transfer method. Great, now we are at 1000 there, and let me execute this. Yeah, so 899, and yeah, the same here, which means 1000 minus 100 minus the fee, you get this number. And yeah, I hope you were able to see how inheritance comes in handy to create subclasses out of a base class. That's it for this lecture, and we have one more lecture to go. And in the next lecture, what I'll do is I'll clarify some terms of object-oriented programming. So that will be a short lecture, and that will help you later on when you refer to documentation, because there are quite a few concepts out there in OOP, and I don't want you to get confused with those. So I think that's an important lecture. Yeah, talk to you later. Hello again, and in this lecture I would like to make sure you know the terminology of object-oriented programming in Python. So now we have the class, which is this blueprint here, or you can call it a prototype that defines the characteristics of an object that is about to be created. So that's the class, and then we have the object instance, or simply the object. So this here is an object, so a checking account object that stores data in this specific file path, and it has this attribute, so it has this fee. Then we have instance variables, and these are variables that are defined inside the methods of the class, like a file path here, and these are accessible by the instance, by the object instance that is created by that class. And then we also have something called class variable, so instance variable and class variables. Now we didn't create a class variable in any of the previous lectures, so I'll go ahead and create one now. Let's create one for our checking account. So that should be something like, let's say type equals to checking. So a class variable is declared outside of the methods of that class. And class variables are shared by all the instances of a class. So instance variables are shared by only the object instance. For instance, let me explain that. Here, this is one of our object instances, so we only have one object instance here, but we could have more. So I'll copy these and create another object instance here, and I'll call this, let's say this is Jack's checking account. So I'll replace that and that and that, and this is John's checking account. And they also have their personal storage there, so let's say jack.txt and john.txt. So Jack has $100 and John has $200. Good. So we need to change that. Jack and John. And if we execute this script now, we will get two values printed out. So -1 for this statement here, because the Jack had, so he had $100 there, but then he transferred 100 and then minus the fee of $1, and then he ended up with -$1 there. He owes the bank some money, and then John had 200, so he has 99 now. So what I'm trying to say is that these variables belong only to their object. But if you try now Jack's checking dot type, so you want to print that, print John's checking dot type, you'll see that this class variable is shared by all the instances of that class. So that's the difference between class and instance variables. Class variables are rarely used, so you'll really have to pass them in here. Another concept now, docstrings. And a docstring is usually passed as soon as you write the class keyword, so just down the class keyword. And that provides the explanation of your class. Let's say this class generates checking account objects. And then you close that with 3 quotes. So what that does is, if we print that out, so we grab one of our object instances, let's say John's checking dot double underscore doc and double underscore again, so print that. So as you see, a docstring is used to provide some information about that class. So it's good to define this string when you're writing classes, so that others, if they use your class, they can apply this operation here, and they can see what your class is about. This is particularly useful when you're importing classes from modules, so when you don't actually see the code of your class, and you can do this, and you have access to the docstring of the class. And then we have the concept of data members, which actually is referred to class variables or instance variables. So this is a data member, and this also is a data member as well. Then we have the constructor, which was this init function. And as you know, the init function, so the constructor constructs your class. And then you have class methods that you apply to your object instance. So transfer is a class method. So this is also a method, but it's a special method, so it's a constructor. And instantiation, if you hear about instantiation, that is the process of creating object instances. So instances of a class. Like this is instantiation of the class. and this one here as well. And you know inheritance now. Inheritance is when you create a subclass out of a base class. And this subclass shares the methods of the base class, plus it has its own methods that are specific to that subclass. Sometimes you also hear about attributes, and attributes are this one here. So when you access these instance variables or even class variables or even instance variables, you can say you are accessing attributes of your class instance, so of your object. And yeah, that's about the vocabulary of object-oriented programming in Python. And I really believe I have given you a solid understanding of object-oriented programming and creating classes and objects and so on. If you still find something confusing, you can either rewatch the videos, because I know object-oriented programming is a bit tricky, but you can even ask questions, and I'll make my best to explain things that are not yet clear to you. And yeah, I hope you found this useful, and I'll talk to you in the next lecture. So we're done with this section, and yeah, see you later. Hey, welcome to this new section, and throughout the lectures of this section you are going to learn computer vision with Python. I'll explain computer vision in a minute. That's what we're going to learn in this section, and then in the next section we'll build an application that detects moving objects from the computer webcam and stores and visualizes the times when the objects entered and exited the video frame. So that's an application area of computer vision. Now, maybe you have an idea of what computer vision is, but if not, I'll explain it now. So, computer vision is the field that deals with acquiring and processing images, and it makes decisions based on them, on the images. So, you pass an image to the computer, and the computer tries to understand it, and it can do certain things, such as it can tell you how many faces there are in the image, and what color dominates the image, and so on. Now, computers are dumb. I mean, you have to tell them what to do exactly, and that's where Python comes in. We'll use Python to load images and process them and do things like face and motion detection. Now, vision includes both images and videos, because videos are simply stacks of images that show very fast. So computers, and therefore Python, use the same commands to read images and videos. And you can do computer vision with Python using OpenCV. OpenCV stands for Open Source Computer Vision, and it's a library used not only in Python but in other programming languages as well to do computer vision tasks. So in this section I'll introduce you to OpenCV, and you'll learn how to use it by detecting faces from images. And then in the next section we'll dive deeper and process videos with OpenCV and detect moving objects in real-time webcam video. That's about this lecture, and let's move on and quickly set up OpenCV in the next lecture, then work with it after that. So yeah, thanks, and see you in the next lecture. Great, so let's go ahead and play around with OpenCV a little bit. Specifically, what you'll learn in this lecture is you'll learn how to load images in Python using OpenCV, and you'll learn how to display them, resize, and then save the resized images in new image files. So load, display, resize, and write images. And I've got a nice image here of a galaxy, so I'll play around with this. The first thing you want to do is import the library. And then the second thing is you want to load the image in Python. So image would be equal to cv2.imageRead method. So the method expects now the path to the image that you want to load in Python, and that would be galaxy.jpg. So my script, the 1.py file, is in the same directory with galaxy.jpg. So I just need to pass the file name here. And then there is yet another parameter for image red, for imRed method. And then this parameter takes 3 arguments. Now this parameter specifies how you want to read the image in Python. So do you want to read it as an RBG image, which means do you want 3 bands in your image? So you want a color image with a red band, a blue and green band. So if you want to read the image as it is, so with colors, you'd want to pass 1 here. If you want to read the image as black and white image, so in a grayscale, you'd want to pass 0. And having a grayscale image implies that your image will have 1 band. And I'll get back to bands and explain them in just a moment. So, and we also have -1, and this means a color image. But you also have an alpha channel, which means your image will have transparency capabilities. So if you apply operations that require transparency, you can do that when you load the image with a -1 argument here. Okay, so I'd like to try out 0. Great. Now, before I show the image, before I display the image on the screen, I'd like you to understand what this image object is about. So I'd want to print the type of it, just like that. Execute the script, script 1. Yeah, of course, and try again. So this is a NumPy n-dimensional array, and if you want, you can print that out, and you'll see the actual NumPy array. So this is a 2-dimensional array with values in the horizontal axis and in the vertical axis as well. So think of the image now, and this would be the very first, so the top left intensity value of the first pixel. So 14, for example, would be the intensity value in the grayscale for the first pixel of the image, so for the top left pixel of the image. And then for the second pixel and so on, and then you have these dots, which means Python cannot display the long list in here, because you have a couple of thousands values in the first row, and then you have the second row of pixels in the image, and the third, and so on, and this makes the matrix of the pixels of the image. And if you want to know how many numbers, how many values you have in the horizontal direction and how many values you have in the vertical directions, you can go ahead and print image shape. Okay, so let's say that the image resolution is 1485 by 990. So Python stores the image as a NumPy array, as a matrix of numbers. As easy as that. If you want to check the dimensionals of your array, of your image, you can do that with this expression, and you see that you have 2 dimensions. Now, if this was a color image, so with 3 bands, red, blue and green, things will change a little bit. So you've got 3 dimensions, and you also see that the new array is a bit different. So here you've got values for each of the bands, so for green, for red, green and blue. So I'd like to stick with the gray image, and what I can do now is I can display the image on the screen. And for that you want to use the image, so imShow method, and this will display a window, and you want to name that window, so you want to put a title for that window. Let's say Galaxy. And what you pass here is the image object, so this one. Great. And then what you want to do is you want to specify a time for your window to be closed. because this will show the window, but you also want to define some functionalities so that the user can close the window. If you put 0 here, when the user presses any button, the window will close. Let me change this to CV2. So if you put 0, the user can close the window pressing any button. If you want to put a time, you could say 2000, and that implies 2000 milliseconds. So that means 2 seconds. So we said how the user wants to close the window, and then you want to specify what to do when the user presses a button or waits for 2 seconds. So you want to destroy all windows. That's a method that closes the window. Good. Let's see what will happen. Okay, so we got the image displayed, and it waited for 2 seconds, and then it closed. If you put it at 0, the image will stay there, and if you press a button, it will close. Let me show the image again. Now, the reason that you don't see the image fit on my screen is that the image, as you see here in these values, is 1485 pixels high. So the height, this is the height, and it's 990 pixels wide. So my screen resolution is set at 1280 by 720. So that means this image with this size doesn't fit on my screen because my screen is too small for this. So in this case, let me close this. What you can do is you want to resize the image and then show the resized image. So we load the image, and before showing it, before passing it to the ImShow method, you want to say, let's say, resize image. That would be equal to cv2.resize, and this would get 2 parameters. So the first is, of course, is the image object that you want to resize. So img is our variable, and then you want to specify a tuple with the new dimensions. I would say 1000 by 500, and then you want to pass the new image here. So what's happening here is that Python is actually resizing the NumPy array. So it will take the array with this number of pixels, number of values, and it will create an array with this new dimensions. So what will happen there is that Python will interpolate those values. So it has quite a lot of values here, but then it goes from this to this. So when it sees, let's say it has 4 for one value and then 6 for the neighbor value. And what Python will do is that it will get 4 and 6 basically, and it will just make a value out of it. So let's say 5. That's basically the idea. So it interpolates the values, and then it shows the interpolated image on the screen, which looks pretty nice in our eyes. Okay, let's see this. And this is the image, and you see that this is quite stretched a little bit. So it was a tall image, but now it's quite wide, and because this is actually the width of the image and this is the height. So if you want, you can say 500 and 1000. Save again, and now you see more or less the true ratio of the image. But if you want to keep the ratio of the image, you'd want to go more advanced here. So let's say from this, so let's say we would want to show a size that is half of this, so that would keep the ratio of the image. So what we can do is we need access to these values, and we can grab those values from the shape method. So this produces a tuple with these 2 values, and then we go here and say image shape, and this would be this value, so 990, which has an index of 1. And then we have again image.shape with index of 0 for this number. And then we want to divide this by 2. Okay, and I expect to get an error from this, but let's see. So yeah, we've got an error. It says type error, integer argument expected got float. But here what we're doing here is that when we divide this number by 2, we will get a float. So we would get something like 742.5. In that case, what we want to do is convert this to an integer. So 742.5 would become 742. Okay, and let's keep the consistency, so integers for this as well. And let's see. We've got an invalid syntax here, so it points us to line 11 somewhere in the beginning, which can be quite misleading. So you want to see before that line, which is here, and you can see that this bracket here closes here, so we need another bracket which closes in the first bracket here. So save that, try again, and this time the image looks good. So you learn how to load an image in Python, and you learn how to resize an image, how to show an image on the screen. And now let's go ahead and write the resized image in a new file. For that you'd want to use the imWrite method, so image write. And you want to give a name to the new image, galaxy, let's say, resized.jpg. And then you pass the image object that you want to store in this file. So the comma goes outside here, and the image you want to store is resized image. That's it. Execute, and we got the old image resized on the fly. So Python gets the numpy array, it interpolates it, so it resizes it, and then it shows it on the screen. So this is galaxy, this one here, and then we can close this, and here we've got our new image, so galaxy resized. So if you go to the folder where these files are, you'll see that this image has new dimensions, so 495 by 742. And that's what I wanted to teach you in this lecture. Hope you enjoyed it, and talk to you later. Well, I hope you solved the exercise, and I believe it was not a difficult one. My purpose there was to get you used with the OpenCV code, and also why not to practice a for loop. So as you can imagine, this exercise would be solved by using a for loop. So let me go through the code line by line quickly. So we have to import OpenCV, so CV2, and the glob library. Now, if you can recall it, what glob does is that it finds the path names of some files given a certain pattern. So in this case, for instance, I have this JPG files here, so 1, 2, 3, 4, 5 images, and I said, okay, create a list of file names that contain everything in the first part, and then JPG as an extension. So that will create a list such as say like C, and then the path here, and then galaxy.jpg, and then the other image path, and so on. You get the idea. And then what we need to do is iterate through this list. For each path, image path in the list, in this list, we'll do these operations for each of the list items. So first we will read that image path, okay, that image file actually, as a black and white image. So 0 is a flag, is an argument which implies an image read as black and white in the grayscale actually. And then we create a variable where we will store the resized images. So the image is 100 by 100. So I'm passing the original image here and the size, the new size that the image will get. Then we want to show the image just for demonstration. This is not really important, but it lets you check out the images that are being resized. And this is the name of the window. And then I pass here a wait key method, and 500 means 500 milliseconds. So each image will show and it will wait for half a second, so 500 milliseconds. And then after this half a second, Python will go to the next line and then to the next, and then it will go to the next item of the list and so on. So wait key 500 milliseconds, and then we have destroy all windows after this time passes. And then we write the resized image. So RE was a variable that holds the image object, the resized image object. And this here, all this, is the new name of the file. So what we get here is, so we will have resized in the beginning of the image name, and then just after that we will have the name of the original image. So for instance, we would have, for Galaxy, we would have resized galaxy.jpg. So image here would be galaxy.jpg here, which is this one here. And yeah, because the script is inside this folder, this list, actually the image list, would look something like galaxy.jpg, and then kangaroos in Australia.jpg and so on. So this gets the relative paths of the files. We're not getting the full path. Okay, I hope that is clear. So resized galaxy, we could add an underscore so that we discriminate the resized word from the other image name. Great. Let me execute this Python script. So half a second, and yeah, it's done. And let's check the images. So from here up are the original images, and these are the image products. So you can see here that all these are 100 by 100, and they are in a grayscale. Okay, that's it. See you in the next lecture. Hey, welcome to this new lecture, and here you learn how to detect faces. And we'll be using OpenCV with Python to detect one or more faces from an image. So basically, how does face detection work? Anyway, well, the idea is that someone has created some cascades, which are basically some XML files, such as this one. And this XML file contains the information about the features that an image of a face contains. So we're talking about ratio of the shadows, so all the eyes and nose and lips, and all these features, these pixel intensity numbers are recorded in this XML file, which has been created by using some images with faces as training samples. So basically you tell your computers, okay, these are all these are faces, and then you use software like OpenCV to create such XML files. So these are called HAR cascades, and this is a HAR cascade for a frontal face object. And if you want other objects, you can find them in this link here. So you've got full body, left eye, and lower body, and so on. Alternatively, you can use the resource section of this lecture. You can download a zip file with all the XML HAR cascades there. But in this lecture, we will be focusing on the frontal face, so we'll be using this cascade to detect faces. The way it works now is that we will load the image in Python, and then we will tell Python that this is a model that you want to look for in the image, and you want to find this model, so the XML model in the image. And what Python will do with the help of OpenCV, it will start to search all the image using a window, and then it will resize the image, so it will decrease the image size and using the same window it will detect for smaller faces and so on. We'll go through that step by step. So let's write the script that detects faces. Import CV2 is the first thing you want to do. And then the next thing is you want to read the cascade in Python. So let's call the variable face cascade CV2, and we have a method called cascade classifier. So this will create a face cascade object in Python, and all we have to pass here is the path of the har cascade. That's it. And that will create a cascade classifier object. And now you can use this cascade classifier object of the face feature to search for a face in your image. So the next thing you might want to do is to load the image in Python, the image that you want to search for a face. Let's say image equals. So you know that we can load images in Python via the image read method of the OpenCV, and you can just pass the photo.jpg name here. So I'm passing the file path of this image. So I'm not passing any second parameter here. That means I'm reading the image as a color image. However, a good idea is to use grayscale images when searching for a face. So I loaded the image here, but I'll be using the grayscale version of the image when searching for a face in that image. That is thought to produce higher accuracy when searching for faces. Because you may notice that when you have very busy images with lots of features, OpenCV will not be 100% accurate, so you may get faces that OpenCV will miss out, or you may get features that will be classified as faces. Using the grayscale image, though, increases the accuracy. I could go ahead and pass a 0 flag here so that I could read this image as a grayscale, but I'd like to actually keep the original image as a color version, because I want to show the color version at the end, but use the gray image to pass it to the methods that will be searching for the face. So I'll create here a gray image variable where I'll store the grayscale version of the image. So CV2, and we have a method called CVTColor, and that takes as argument the original image, of course, and a flag, so an argument called CV2Color BGR2 gray. So what this means is that this will convert the BGR image, so blue, green, red bands, it will convert it to a grayscale image. That's it. So if you want to quickly show this gray image, if you like, CV2 show gray image there, we give a name for the window, gray, and the image you want to show, and you need to pass the wait key parameter here, let's say 0, so we'll press any key and it will close the window. CV2 destroy all windows. So you learned these methods in the previous lectures. Let me execute this. So this is a grayscale version of the image. And now we will use a method called detect multiscale. And what this method will do, it will search for the cascade classifier. So it will search for this frontal face XML file in our image, and it will return the coordinates of the face in the image. So for instance, this is the image, and what this method will return is it will find the face and it will say, so it will give you the number of the row and the column of the upper left point of the face. So it will start here, and it will also give you the height of the face and the width of the face. So we get a rectangle, and then we will draw that rectangle in the image. So that's basically, but you'll understand it better. And so we need to create let's say a faces object variable, where we'll store this x, y, width and height values. So let's quickly grab that. So we need to refer to the cascade classifier object, which is this one here. And what we want to do this with this object is detect multi-scale. And you want to detect the gray image. And then you want to pass a scale factor in there. You know that when you have lots of parameters and they are too many to fit in a line, after the comma you can just press enter and Python will read your line as it was one single line. So but be sure to just press enter after the comma. And so we have scale factor. And a good value to give for this would be 0.5. Now what does this mean anyway? Well, let's consider this image. What Python will do is that it will start from the original size of the image, and it will search, it will create a window that will search for faces in the image. So search in this area, in this area, in this area. And so once it does that, then by giving a scale factor of 1.05, you're telling Python to decrease the scale by 5% for the next face search. So what Python will do is it will downscale the image by 5% and it will research for bigger faces in the image. So search again, and then decrease it by 5% again the image and search for bigger faces, and so on until it goes to a final size. So that means a smaller value means higher accuracy. If you give, for example, 0.5, Python would decrease the scale by 50%. So it will start from the original size and then it will go 50% higher, and so you don't get much accuracy with that. The profit with this number is that the script will run quicker, so you'll have less passes to the image for searching for a face. 0.5 is good. Okay. And then you have another parameter called minimum neighbors. And that is usually set to 5. And what this basically is that this tells Python how many neighbors to search around the window. So you may want to experiment with these numbers a little bit and see which gets the better results. But these two are well accepted numbers. So let's do something now. Let's print out faces and see what this is about. So what kind of object this is. And I could also print the type of faces, just like that. So I'll run the script now, and what the script will do, it will read this XML file and it will load the image. It will make the grayscale version of the image, and then it will detect the coordinates of the upper left corner of the face in the image and the width and the height of the rectangle defining the face in the image, and then it will print out the type of the faces, and it will print the faces, the actual faces object. So okay, press any key to exit this. And so faces is a NumPy array, an n-dimensional array object, and it is an array with 4 values. So we have detected our face, and these are the values basically defining the face in the image. So basically what we have here is, so this is 155, which should be the 155th column. So this is the X, so it's the rectangle should start somewhere here in the forehead, and this should be 83, so the row 83, column 155, and then we have the width, which is 382, and the height, which is the same, and so we have a rectangle in the face. Now let's go ahead and draw that rectangle in the face, in the image. So we created the faces array, and then what we want to do is access all these values of this array. To do that, we can use a for loop. So for x, y, width and height in faces, well, image. So we are updating the image object that we have read here, we have loaded here. So we will update it by drawing a rectangle in the image. And again, you need to pass the image object in here, and then you need to pass 4 more arguments. The first argument would be the starting point of the rectangle, so that would be x and y, so these coordinates of the face array. Great. And then the next parameter is another tuple defining the coordinates of the other corner of the image. So we've got the top left corner in here, and we got the lowest right corner in down here. So what that would be is x plus the width and y plus the height. That's it. Yet another parameter, this would be the color that you want to give to this rectangle. So, and that comes as a BGR format. So you want to pass a value for the blue color, so let's say 0 for blue, and let's have a green rectangle, so 255 for green, so we'll have a full green there, and then 0 for red. And you can also pass another parameter, which would be the width of the rectangle, let's say 3. Okay, and once you do that, so once you have updated your image, you may want to show your image window on the screen now. So we use the image show method, but here we have a gray image, so we want to pass the updated image object, and we should be good to go. Save the script, go and try to run it. And my system is not being able to find the face detector.py. Yeah, I've messed up something with the name here, so let me change this. .py, enter. So nothing to do with the script, and let me try again. Great. So I hope this is what you were expecting. So the rectangle starts here, and it has a width and a height, and it ends up in here. Sometimes though, as you might already know, you may have images that are bigger than your screen resolution. In that case, your image would not fit in your screen on your screen, so what you could do is resize the image before showing it. So let me create a resized variable here, and that would be equal to cv2.resize, and you want to pass the image, so which contains the rectangle there, and you want to resize the image to these 2 values. So you need to set the resolution of the image here, and as you know, you can just put some values here, let's say 500 by 500, but these values might stretch out your image, so a better solution would be to access the shape of the image, so the resolution of the image, and this should be the width of your image. So you already know this, I explained this, so I'm just going through this quickly. And to make sure you get a good size, you could divide it by 3, and then again image shape, you get the height, which is the first value of the tuple, and divide it by 3 again, and you also want to convert these to integers, because you might get float numbers, and Python will say that it cannot resize an image to float numbers, so that should be okay. And then you want to show the resized image. Quickly testing it. I'm missing a bracket here, so this should be a tuple, all of these, but here I'm not starting it as a tuple. So the bracket here and closes in here. That should work now. Yeah. So this was my picture, but let's try a more challenging picture now. This one here. So we've got two faces which are not very clear. This is not a real frontal face. This guy here, he has his eyes closed and his chin is not visible. And we've also got these two faces here in the newspapers, which, let me open the original image from here, which have basically very low resolution, and I think Python will not be able to detect these two faces. So let me check this. Here's our face detector, and we want to pass the name of the new image file. Save the script and go ahead and run it. So we've got some back to reality here, and as you see, this time Python and OpenCV were able to detect this face, even though it's not in a very frontal position, and obviously it was also able to detect the hand of this guy, so Python reads it as a face. And what you can do in this case is to tweak these values here, so the scale factor and the minimum neighbors. And something you may also be interested to know is the faces array here has two lists in this case. So this is the first phase, the coordinates of the first phase, and then the second phase, which in this case happens to be a hand, but anyway, you get the idea. So probably by maybe using a 1.1 scale, you may be able to get rid of that hand. So yeah, that's it. You can also try out to detect the face of this guy, but I don't think you'll be able to do it. So just that you know that these techniques have limitations. So it's a computer, it's not a human being, so it will always have some downsides in the accuracy. I hope you found this useful though, and I'll see you in the next lecture. Hey, welcome to this new lecture. And in this lecture, we will be using OpenCV to capture video from the computer webcam. So you'll need OpenCV, and you will import it as CV2, as you already know. OpenCV is what we use for image processing, and of course video processing, because video is made of images. So we have lots of images, and they are referred to as frames. And these frames, these images are showing one after the other in a high speed, and then we can see those images as a video. And you'll either hate this lecture or love it. What we'll be doing is that we will go in a really low level of image processing here, of video processing. We'll be reading frames one by one, so images one by one. And you'll see that how we use loops in Python to show those images and to actually build a window where images are showing fast and you can see it as a video. So if you have a laptop, you probably have a built-in camera. If you have a desktop without a camera, you'll need an external camera to follow me in this lecture. And now, the first thing you may want to do is to read a video. And then once you read a video, so you can read a video either from the webcam or from a video file. And once you read the video, then you can apply other operations, such as graying out the video or adding text to the video or detecting objects in the video, etc. So the first thing you want to do is to create an object, let's say video, and that will be equal to cv2.video capture. So that's the method that triggers a video capture object, and that gets an argument here, which can be either a number such as 0, 1, 2, 3, or the video file path. So when you put a number, that implies that you're capturing video from the camera. So let's say I have a built-in camera in my computer, but also have an external camera. In that case, one of my cameras will have an index of 0, the other camera will have an index of 1, and if I have a third camera, it will have an index of 2, and so on. So that's it. If you had a video file, you could just say movie.video MP4 or something like that. It depends on your video file name, and you'd have to have this file somewhere in your computer. But in this lecture we are talking about capturing video from the webcam. So I have only one webcam in my computer, so I'll pass a 0 here. That's it. Once you do that, you want to make sure that you will release the camera. So you want to access your object, video.release is the method, and then you don't need to pass any arguments there. So let's see what we have if we execute this Python file. So Python capture.py is the name of my file, and obviously nothing happens. But on my side, I noticed that my camera was turned on for a second, or for a fraction of a second. So the light of the camera was turned on and then it was closed. It was turned off immediately. So what happens is that we actually trigger the camera here, the webcam, but then we immediately release the camera. So what Python will do is it will open the camera, and in a millisecond or so it will release the camera. Let me try it again. Sometimes it might happen that you don't even see a light at all. So you don't see it because the process happens very fast. So probably your computer needs some seconds to actually turn on the light of your camera. And we can give it some seconds. So to do that, you want to import the built-in time library. The time library provides some operations related to time. So for example, in our case, we will use it to hold the script for 3 seconds. So what this will do is that Python will try to execute the script line by line, so it will import CV2 and time, and then it will trigger the camera, and then before releasing the camera, we will have the script wait for 3 seconds. So this will be executed, wait for 3 seconds, and then execute the other method. That's it. Now, let me execute this again. Okay, the light is on, 1, 2, 3, off. Yep, and the video is released. Now, maybe you're thinking, why don't we see your face there showing up in the video camera in the window? Well, the reason is that, do you see any line here that I'm showing a window? No? So why do you expect my face to show there? And the way we do that is by first creating a frame object which will read the images of this video capture object. And let me do that first before going into more explanations. So let me say check frame. That would be equal to video dot read, just like that. So what we're reading here is we have a boolean data type here and a numpy array. So let me print this out so that you understand better. So check first and then print frame. Okay, execute the script. Okay, wait for 3 seconds and close it. So what we got here is, I'll expand this. So we got true for the check variable, and we got the numpy array which represents the image. This image is actually the first image that the video captures. This here, the boolean, we can use it for various operations such as checking whether the video is running or not. So you may have to check that while doing your programs. And the frame is the most important one because we will use this frame object, so we'll use this numpy array, which is a 3-dimensional array because it's a color image, so it has 3 bands. And you know this from the previous lectures where we did image processing. Okay, and we will loop through this frame and show it using the image show method, so imshow, image show method of the CV2 library. So we will recursively show each frame of the video being captured. So I hope that makes sense. So before we do that recursively, I would like to show a window down here. So cv2 I'm show, and let's put a name for the window, capturing, and then pass the frame object in there. And also remember that when you pass an image show method, so when you're showing a window, you want to make sure that the window is closed, and you do that using the cv2.wait key methods, and you can pass 0 to allow you to press any button and close that window. And what you want to do is cv2 destroy all windows. So when this button is pressed, you destroy all windows. And actually you want to put this up here so the video is not released before you press this key. So what happens is that Python executes these lines, and then it waits for you to press a key, and then it releases the video, and then it destroys the actual window that you're seeing on the screen. Okay, let's see what will happen now. Surprise, I've got only 2 teeth. You didn't know that. Okay, I'm joking, I have more. But so what Python did here is that it triggered the camera. So it triggered the camera here, and then it read the first frame of the video. So the very first frame, as soon as the camera triggers, it reads the first frame, and then we printed out that frame, and it's here somewhere in the command line. Then the script slept for 3 seconds, so it didn't do anything. It waited for 3 seconds, and then cv2 with the imshow method, it created a window where it showed the first frame of the video. So the picture that you just saw is the first frame of the video. And then the actual frame, the window, is still open, so it's waiting for a key for us to press. So if I press a key now, these last 2 lines will be executed. So that means the video will be released and this window will destroy. So press key, and yeah, that happened. So Python is processing a video frame just as simple images. That means you can also apply methods such as cv2.cvtcolor, and you can pass that frame in here, and then cv2 color bgr2 gray, save it in a gray variable. So what I'm doing is that I'm converting the frame, so the color frame, into a gray image. And actually I have to do this up here. So, and then I can show the grayscale version of the image here. Okay, let me try it again. So that's the grayscale version that is showing using imshow method. So that's the idea. Now, how about showing an actual video, not a single image there? Well, the answer is that we need to use a while loop here. The reason we need to do that is that a while loop, what it does is that it executes some statements infinitely until you break the loop at a certain point using statements such as break, for example. So the idea is that we need to put all this code up to here, so we need to put it in a while loop, and I'll do just that. So you can either use a shortcut from your keyboard, depending on your keyboard, or go to edit lines and then indent to indent these lines. So here is a shortcut, but anyway, then you want to write while true, and then everything goes inside the while loop. As easy as that. But we haven't finished yet. We have some more things to do here, but first of all I'd like to actually make sure you understand the while loop. So let me trigger a Python console here quickly. So what while loop does is that, let's say while true, print, let's say 1. If you execute that now, 1 will be printed infinitely. So my console is getting very busy here, and I can interrupt this using a keyboard interruption operation, so Control C or Control Z if that doesn't work. So the while loop is saying while true, which will be always true, execute these lines. But if I try to run this now, what will happen is that Python will trigger the capture, the video capture, and it will show the window, but it's just one window only, so just an image is the first image of the video. Because what's happening is that the while loop starts, but it creates a frame, the first frame of the video, so the current frame, which is the very first frame where the video starts, and then it converts the frame to a grayscale image, and then it sleeps for 3 seconds, okay, and then it shows the image, and then what the while loop does here, it waits for you to press a key, and then if you press a key, the process stops. So what you can do in this case is to enter another, let me make some space there, so you need to alter this value here, so the arguments. When we enter 0, it means that any key that you press on the keyboard, it will close that window. But if you enter, let's say, 2000, that means the script will wait for 2000 milliseconds, which is 2 seconds. And let's see what will happen here. So it shows my face first, and then it waits for 3 seconds here, then it waits for another 2 seconds, and then it shows the other frame, so it's very slow, just like that. Okay? Now if you press any key, nothing will happen because you remove the 0 from here. So in that case I'll forcefully stop the script here. Control C. Okay, we don't need this time sleep anymore, and we also need a conditional here. And before doing that, we'll store this action in a key variable, and then we say if key is equal to or the method, and then you pass a key from the keyboard. So if this equals Q, then break the while loop, and let's put it 1000 this time. Okay, so now what this will do is that it will capture the video, it will start the video, and then it will iterate through all these lines. So it will create a frame, convert it to gray, and then show the frame here, and then it will wait for 1 second, and if you press the Q key from the keyboard, it will break the while loop, and then if it breaks, then the video.release will be executed, so the video will stop and the window will be destroyed. But if you don't press any key, this will wait for 1 second, and then it will show the next frame, and then after 1 second it will show the next frame, and so on. So save the script, execute. So the video is improving. Yeah, looks good now. Okay, if you press Q, you'll stop it. Okay, let's improve it more. Why not 1 millisecond? Hey, how we're doing? So it's working good. And you can also see here that the check boolean, the numpy array, is being printed at every iteration. And we can stop this now if we press Q. Just like that. Now, if you want to know how many frames are being generated there is a nice trick we could do. We could create a variable, let's say a equals to 1, outside the while loop. And then here you say a equals to a plus 1. And then after the loop breaks here, you want to print a. So what this will do is, When you run the script, A gets a value of 1, and then when the while loop starts running, so it will go through the first iteration, and it will increase A value by 1, so A equals to 1 plus 1, so it will be 2, so A will be updated to 2, and then it will go up to the end, and then it will start up again. So this time it will be A again equals to 2 plus 1, so A will be 3 at the second iteration, and so on. Or you can put this to 1 actually. So if we have 2 iterations, that means A will be 2, and if we have 3, it will be 3, and so on. And then we print A here outside the loop. Okay, and let's see what we have. I'll keep the video running for 3 seconds, and we'll see how many iterations we'll have. So capture 1, 2, 3, and stop. So the last value that was printed out here is A value. That means we had 51 iterations in about 3 seconds, which is, let's say, around 20 frames per second. So our camera, my camera, is capturing 20 frames per second. And let me execute this one more time, the last time. So if I put my finger here in the camera, so I blacked out the image, and you see that the numpy array is now 0, 0, 0. Because the frames of the image, all it has is 0 values. So there's 0 intensity in the image. Okay, that's what I wanted to show you in this lecture. So as I said, once you have these frames, you can apply operations to them, so you can draw rectangles there, detect images, and so on. And we will do that, so we will build our real-world application by implementing some motion detection in our frames, and then we will capture the times that an object enters our frame, our video, and we will have a list of those times. So I hope you loved this lecture, not hated it, and I'll see you in the next one.